So in this series, we're going to focus on building enemy AI with LimboAI behavior trees and a player character using LimboAI state machines as well. And for getting our assets into the game, I'm using Aseprite Wizard in order to quickly set up animated sprite 2Ds. Hello everybody, Chris here, and in this video I want to show you guys how you can use the Aseprite Wizard to relatively quickly import all of the animations for a character into Godot and then assign it to a animated sprite 2D. So the plugin would be found at Asset Library, and then you can type in Aseprite Wizard, right? So it'll be right here, and you just download that, install it to the project, and then you go to project settings. Inside of plugins, you enable it. So currently I'm running on version 8.2, and this is Godot 4.4 Dev 7, I believe it's almost fully released anyway. So then once you have that, you will need to either create and animate in Aseprite your own characters, or you can import a pack with some already. So as a example, if I collapse everything right here, we can see that I am using the Treasure Hunters pack right now by PixelFrog, which is available on itch.io for free. And in each of these characters, they have the Aseprite files in addition to PNG sprites. So rather than having to assign all of the PNGs to animations directly, we can just import the Aseprite file. So to do that, we open up Aseprite, and then we want to click on one of these Aseprite files, go over to the Import tab in the top left, and then there should be this option to import as, and it's going to default to no import. But for a character, you want to import it as sprite frames. Okay, so if we click on the import as, there's a few options in the drop-down menu. You're going to want to select either sprite frames, which is what I'm using for this video, or a sprite texture, which is going to convert it into a atlas texture. But if you want things to just kind of assign automatically, you have all the animations already loaded here, then I think the most straightforward way would be to use Aseprite sprite frames. Then you probably won't need to do much here, but you can exclude certain layers using a regex pattern. So here I'm just trying to exclude the grid layer from the export so that the background doesn't come in, basically. So we would hit import here, and that'll load up the sprite frames. So before we do that, though, you may want to check the editor settings, and then go down to Aseprite, or you can type in Aseprite, and we're looking for Aseprite General. So here we have the path to Aseprite on the computer, and Aseprite is a paid program, so you do need to buy it on Steam. I think they also have it on itch.io, but if you have a copy of Aseprite, you point to the file. By default, it's just going to say like Aseprite here, so you can also just use the default set to the path. Running on Linux, though, I, for whatever reason, had to directly assign the path here. Not sure why, but when I did this, it worked. So this is the full path directly to the executable. And so we can go to import. I have grid being excluded from the export layers, and then we re-import. So that is going to give us this sprite frames. And then you take the sprite frames resource, you go to an animated sprite 2D, and then you just drag and drop it in. So that's going to load up all of the animations here for you to use. So you can see that this is very convenient if the animations have been set up properly. Then you basically don't have to do much work here really in general. You can just kind of play the animations. So what's handy about animated sprite 2Ds is that they're straightforward, don't really have much complexity. And I think for side-scrolling characters like this, it works really well. So not going to get into too much detail here, but if you do want to add extra functionality to your animations through a animation timeline, then we can use a animation player here. So I add an animation player, and then we can create an animation here. So kind of giving it the same name of, let's say, idle. And then we can do a call method on the animated sprite 2D. And if we insert a key here, we can play the animation we actually want it to play. And if we click over here on the right to loop it, and let's set it to autoplay on load, then if we run the main level, which has this character there, then it should autoplay that animation. And then we don't need to worry about like assigning the frames inside of here or whatever. We just need to tell the animated sprite 2D to play the animation which already exists. And because we have this timeline, we can add in a whole bunch of other things that can happen during the animation playback if we wanted to, like, I don't know, changing the color of the character, for instance, as a property change, if we targeted the animated sprite 2D there. But yeah, just an example of how you can kind of extend that from an animated sprite 2D. So kind of more in the workflow that you would usually do with a regular sprite 2D. So if you don't need any of that though, which is probably the case for a lot of platformer games, then we might not even need the animation player. And what we can just do is have a script that tells this animated sprite 2D to play the animation we need at the given times. So in the next couple of videos, what I want to do is take LimboAI, which is a behavior tree and state machine plugin, and use it to kind of control this character and also this other character, which I need to re-import, using a state machine for the Captain Clown Nose player and a behavior tree for the Krabby character. And then we can play the animations in whatever other code we need at the right points, the right states, whether the character is idling, jumping, attacking, falling, so on and so forth. So just to kind of re-demonstrate the loading of the sprite frames, which is pretty straightforward, I will find the Krusty Crew character. So let's get the Krabby. So double click on this, go to import, re-import. So we have the sprite frames loaded up. And now I take that to the animated sprite 2D, and I just drag and drop this resource right into there. Let me do that again. And then if we click on animated sprite 2D again, we should have all of the animations loaded up here. So yeah, once again, if you are trying to import and you have a background layer, then just try to make sure that when you are importing that you somehow filter out the pattern using regular expression. So yeah, once again, if you're importing your sprites and there is a layer that you're trying to remove, you could either exclude it with a pattern, or you can check visible layers only on, which would help. So the regular expression here is just really simple. So any layers that end up matching your regular expression just get filtered out. So that's pretty much it for this video. I just wanted to show how I got the animation set up before I continue with the next couple tutorials. So until my next video, I've been Chris. Thanks for watching to the end, and I will see you then. Hello everybody, Chris here, and in this video I want to show you how we can take characters that already have animations imported into Godot. So in this case, I'm using an animated sprite 2D, and all of the animations were imported using Aseprite Wizard in the previous video. And we're going to take this and add LimboAI in order to control the character's states as well as the animations using a finite state machine. So for player characters, I think a finite state machine makes a lot of sense because as you press keys, it's going to switch between specific states, and in those states, the character has specific abilities. But for other characters like enemies, we might use a behavior tree since we need to control the state through code-based decision making. So we can customize that in a flexible way using a behavior tree and its resource editor. So that might be the next video, but for this one, we're going to start with the finite state machine for the player character. So in both of those cases, the plugin I'm using in order to do that is LimboAI. So we can get LimboAI from the asset lib. If we go over here and we just type in Limbo, it should be one of the first that pop up. So right now I'm editing on 4.4-7. So I'm going to use the newest version, which is the one for Godot 4.3. As far as I've seen, it still works just fine. I'm going to download this into the project. Now inside of here, there's the add-on itself. There's also demo files. I don't need the demo for this video, but you could go ahead and check those out if you need some other examples. So what I'm going to do to disable the demo from being installed is click over here on the left where we have this arrow. And then I'm going to minimize this LimboAI and uncheck demo, which is going to uncheck everything in the subdirectories as well. So we install this to the project. Now, even though it goes in the add-ons folder, you don't actually need to enable it as an add-on. So if you go to project settings, plugins, you'll see there's nothing there. That's okay. What you should see though is a new tab pops up to the right of asset lib up here. So this section is here for creating behavior trees, which sets up the logic for controlling how an enemy might operate in your game. But for a state machine, instead, what we actually add is a new type of node to our character scene. So I'm going to right click on my Captain Clown Nose and go to add child node. And I'm going to search for Limbo HSM which is hierarchical state machine. So we add that in. And so the state machine allows you to switch between various states. The first one on the list becomes the default states. And through code, you can set what the conditions for switching from one state to another are and how a character would operate inside of those states. So in a regular node script, you have process functions that run all of the time. But for a state machine node, you'll have a specific update function which only runs while the character is actually within that state. And that's how you can make it so that certain code only operates when it's in the appropriate state. That's really handy because let's say your character's in the air state, you might not want it to be able to do a ground swing attack. So you would not have that functionality enabled up here. But when it's in a ground state, you could allow it to do a ground swing. Anyway, to get started, we're going to want to right click on the state machine node and add a child node. And we're going to be looking for limbo state. So right there, just add a limbo state. I'm going to rename this to be idle state. And we need to attach a script to it so that it actually has code to execute. So the state node itself doesn't really do anything. It's just a template that we build from. So I'm going to right click on the idle state, attach a script, and we can just put this in player/idle_state.gd, inherits from limbo state. That's good, great. And then this will be the idle state for the player character. Okay, now in order to make sure that this state machine is actually operating as soon as we launch the character, I'm going to actually add a script to this as well. So let's right click here and attach a script extending from HSM state machine, and let's create. And this will be the state machine for the player character. So in order for the state machine to actually run, you need to tell it what the character it's operating on is so that that character can be passed into the other states as the agent. So I'm going to do an export var here, and I'm going to put in a character that we want to use. So for now, this could just be a character body 2D. So that's going to be like our root up here. And we want to assign this in the inspector. So when you save the script, character should be able to be assigned as the Captain Clown knows if you're working from the same template as I am. And by the way, the before and after for the projects, I'm going to have those on Ko-Fi and Patreon down below as well. So you can use that to follow along if you're not already. And then on ready for the state machine, I want to initialize it. So initialize is already a function we can call, and we need to tell it what the agent is. You can see that this can be any node, but we're building a state machine for a character, so it makes sense to use the character body 2D here. So we start this machine, and the character is the agent that the machine is using. I think you also need to set it to active. So just in case, I'll say set active true. That might be unnecessary. I think initialize might already do that, but just in case, that should have it set up. Okay, so what this is going to do now is it's going to default the idle state to be the one that this is operating in. In order to see what state the character state machine is actually running, I'm going to create a label above the character for debug purposes. So let's right click on the Captain Clown nose and add in a label. And this label is going to be, let's call it state label because it will display the current state. I'll right click here, attach a script. Okay, create that. Shows the current state of the state machine as text. Okay. Okay, so I want to reference the state machine. So I'm going to say export var, and we can say limbo HSM, just any state machine from limbo. So this is going to be of type limbo HSM. And what I'm going to want to do is have the setter function connect to a signal from the state machine so that I can easily read whenever the state changes on the state machine. So I don't need to create a process function and just grab the state on every single frame. That's pretty inefficient. What I can do instead is add a colon here and do set values. So we're creating a setter for the property. And I'm going to disconnect from the old limbo HSM if one exists. So if limbo HSM does not equal null, as in it's already been set to something, then I'm going to disconnect from its active state changed signal. So limbo HSM.ActiveStateChanged.disconnect, and we're going to put a callable function in here. We haven't created it yet, but I'll call it onActiveStateChanged. I'll zoom in a bit here as well. Okay, and after disconnecting from the old one, we want to set the state machine to the new value. So basically when the setter runs, we still want to make sure that the property actually receives the value here. That's important. And then I can just copy this code down here and change disconnect to connect. because now the new one has been set, so we want to connect to it. And then down here at the bottom, function on active state changed. So this callback is going to receive two parameters, which is the current limbo state and the previous limbo state. We're not going to use the previous one in this function, so I'm going to underscore it, underscore previous of type limbo state. So the only thing I need to do here is to say that the text of this label is equal to current.name. So the name of the state, which we just entered, is going to show up here in the state label. Now, also, when we set up the new state machine, we do want to make sure that this is initially set at least. So I'll say right after setting a new one that's not null here, we'll get the current state, var current state equals limbo hsm dot get active state. And then we'll say if current state is not null, basically, then we'll say the text is equal to the current state dot name. Okay, this means on initial set, we're going to have, so this means that on the initial set of the state machine, we grab the name, we set that to the text, and every time it changes, we're going to update the text there as well. So now we just need to assign the state machine in the top right, limbo state machine, save that. So now we can go ahead and hit play, and we'll see idle state showing down here. So we know what state the state machine's in, and that is a helpful bit of debug information. With the state label, though, I'm going to hit W to go into move mode. I'm going to move this up here above the character, right around there. And now if we hit play, well, we'll see the state shows above the character. That's just a personal preference. Now, the idle state doesn't really do anything right now, but what I want these states to do is play a certain animation when the character enters the state. So that'll be handy for controlling the animated sprite, essentially. So in order to do that, first I need to reference the animated sprite somewhere within the idle state, either through the blackboard, which we really haven't talked about yet, or we can set a variable on the agent, which I think for this case actually makes a lot of sense. So in the root, we already have this little script here. It's basically the default character body 2D controller script. That's like a built-in template for Godot 4. I just changed a little bit here in the previous video, I believe. But let's add in a reference to the sprite. So if we do @export var sprite, animated sprite 2D, and this doesn't necessarily have to be an animated sprite 2D. You could also mostly make this work with a regular sprite 2D node as well. They just are set up a little differently. An animated sprite 2D, the animations are stored in the sprite, but with a sprite 2D node, you need an animation player, which is a little more complicated, but not too hard to set up. Okay, anyway, we have the reference to the sprite on the player script. So we assign that, animated sprite 2D. And remember that we're setting the character body 2D node as the agent for the state machine. So if I was to open up idle state or another state, I could reference the agent.sprite, and I'd be able to grab the character body 2D's sprite node. That'll only work if the script actually has a sprite property, by the way. So just be careful about that. But what I want to do is actually make a extended script from limbo state so that when we create the move state and any other state, they can all have a on enter state animation playing. Okay, so in my file system, I'm going to go and do characters, and let's right click here, create a new script. This is going to extend limbo state, and I'll call this character state.gd. If I can type. Okay, great. Let's open that up. And this will be class name character state. And now I can put in the logic needed for setting a default animation up whenever we enter a state. Okay, so first off, I need to know the name of the animation. So I'll do @export var animation name. This should be a string name, or a string works fine too. So now that we have the animation name, we can implement the enter function. So function underscore enter. When a limbo state is entered, as in the state machine selects this state as the active state, then we can have it do certain things. So we're going to get the agent and then the sprite, and we want the sprite to play the animation name. So that's really all we have to do to tell it to start playing the animation. Okay, so now with that, we want to go back to idle state and make this extend character state and hit save. Now we'll get the property for animation name. So in my character, the animation I want to play for idle is going to be idle with sword. So idle space S. So if I go to idle state and I type in idle S, okay, and I save it and hit play, then we'll get the animation to play. Okay, now we want to be able to control movement and switching to a move state where it actually plays the move animation instead. So what I could do is create another character state here. So if I right click, add a character state, which is that custom class name we just created. And then I rename this to, let's say, move state. And let's right click, extend this to a move state.gd saved in the player folder. Then I'll save that there. I'll comment move state for player character. And then for the animation name, we'll put this as, I think it's move. I think it was move with S, but let me check the sprite. Maybe it's run S. Yeah, run S. Okay, so run S. Okay, so now there's two states here. One that's going to play run S, one that's going to play idle S, but there's no way to switch from idle to move. So we need to basically get the input from the player, save that to a variable that we are referencing inside of our state machine. So we could put that on the blackboard, for instance, and then use that input to determine, first off, that we're moving, apply the movement to the character, and then we can transition based on the velocity of our character between move if we're moving and idle if we're sitting in the same place. Okay, so first off, for grabbing the player input, if I jump into the script for Captain Clown Nose, we can see that it's already grabbing the input here. So we have the jump just pressed, and we have the get access on move left and move right for the player's input. That's only being stored locally for this function, and then it's cast aside. But what we actually need to do is to tell the idle and move states about this information. Okay, so what we need to do is to take this direction and set it onto the blackboard for the state machine so that the states can use that for determining how they should move and if they should change states, essentially. So the blackboard, you can just think of that as a big dictionary of various information that is shared across LimboAI in the state machines or your behavior trees so that your states can read and access it. And you can also set information to it from outside of the state machine itself. So just a dictionary for saving and reading information from. Okay. Now, in this case, I don't particularly like that the input and the movement logic have been put in the same area, and I kind of want to separate that from the root node as well. So I'm going to right click on Captain Clown Nose. I'm going to add a child for a node, and this node I'm going to rename it to player input. So we're going to attach a script to here, and this can just go in player input. If we like, we can give it a class name as well. Player input. And so this script is going to read from the player's input and assign the values to the blackboard so that other scripts, namely the states, can read from it and operate as they need. So this means I'm going to take the logic out of here, especially this bit right here, and post that in here. So we'll have a process function because we're going to read this on every frame. We do want to know if nothing's being pressed, so we don't necessarily do the input function. We want to update this on every frame. So var direction is equal to input get access. So this is the left key, and then this is the right key, so A and D on the keyboard. Don't need that little semicolon there, I think. But why we're getting the error is we're not referencing the player actions resource in here. So I will put that in at export var player actions, and this would be player actions. Okay, and we can just quick load that on the side from the already existing resource, which you can see defined move left, move right, and jump. Okay, so the input direction, I'm actually going to get that as a vector now. So we're going to also add in move up and move down actions to both player actions and the input map. We're still going to jump with the spacebar, but I just want to know basically if the player is pressing up or down as well. Might be useful in the future. So if you want to do that, go to the input map on project settings and do move up, move down, and then move down. Add in W for up, S for down. Okay, now we can go in here and change this from get access to get vector. So instead of returning a float, it's now going to return a vector2, which is just a x, y float values. And we want move up as the negative here. So player actions dot move up. Haven't defined that string yet, but we will in a second. Player actions dot move down. Okay, now we can go into player actions. If we right click here, look up symbol. So let's set those values as well. Move up, string name. It's going to be move up, at export var move down, string name, move down. So if I haven't explained this before, the whole idea of this player actions resource is that I'm just keeping basically a list of all the strings that I would be using for action names within the game. So if a bunch of different scripts are using these action names, then I can keep the name consistent by basically having one shared resource here to hold all of the actions. Also, it would be handy when you're editing, let's say, game settings in game, that you could update the player actions and then have one script for saving and loading those to and from a file if you need to. Okay, so essentially shared names for import map actions relevant to the player character controls. Okay, and let's go back to player import, a little over here on the left. So we get the vector from move left, move right, move up, and move down. Okay, so now we're getting that vector2, we're saving it to direction, but we don't really need it as a local variable here. We actually want it script-wide, and we want to update the blackboard for the state machine. So let's get a reference to the blackboard. In order to do that, you actually need to reference the state machine, and then on load, you get the blackboard from the state machine because the blackboard is created after the game starts, not right now in the editor. So we do a export var limbo HSM. So I'll type limbo HSM, of course. I'll assign that in the inspector. Okay, and then we'll do var blackboard. I'll type blackboard, and when the script is ready, then we're going to get the blackboard from the limbo HSM.blackboard. Okay, so now those should be referencing the same thing. And once that's set, then you can take this direction and you can set it to the blackboard whenever you update process. So I'm going to also make this a local property. So var import direction, which is vector2, and then I'm going to make this actually set down here. So instead of var direction, it's just input direction. So now we're updating the script property. Okay. And from here, there's a couple ways you can handle it. You could do blackboard.setVar, the var name, which we could say is like direction, and then the value is import direction. That would be fine. Another way you can change it is that whenever you update input direction, you just automatically set the blackboard value. So you could do that with a setter, doing the same thing, set var. Or after you grab the blackboard, you can do blackboard.bind var to property. So the var we are binding, as in creating a synchronization between what it stores on the blackboard and what's stored in this local script, will be, let's just say direction, and then the object is self, the property is import direction. And then we'll have this create the variable inside of the blackboard automatically by setting this to true. Okay, so this should make it so that whenever this is set and whenever the blackboard var is set, that they will synchronize with each other. So one way to prove that that's actually working would be to say prints blackboard.getVar direction. Okay, so let's hit play, check output. Okay, and I'm going to move around. Okay, and you can see that it's actually printing the X input here. So the Y is nothing until I press W and S. But yeah, you can see that it's actually grabbing the value there. And it's updating whenever input direction sets. So that's handy. We can get rid of this debug information. And what I might want to do is also create a list of names that are going to be used across blackboards in the game. So just keeping the variable names consistent. So I'll create a new file. I'll call it BB names for blackboard names. So let's say in characters, I'll right click, create a script. This will be BB underscore names, create. I'll open it up. It does not extend node. This is just going to be a class name, BB names, and it's going to be a bunch of static variables. So kind of like with the player actions, but this is more of global because they're all static. So you don't actually need to reference a resource or a node. You just reference the class name and you can pull whatever the string name is. So static var, let's say direction var is going to be a string name and it's equal to direction. Okay, now that that's saved, I can go into the player input and I can replace this with bbnames.direction var. And now we have one variable that we'll just share that name across anything that uses the Blackboard. Once again, not required, just reduces the amount of strings you have to change all of the names of if you update it anywhere else. Okay, so we have the move direction and it's being saved onto the Blackboard and the direction property. If we want, we can go to Limbo HSM and we can start creating our Blackboard plan. So if I create a new Blackboard plan here, this will automatically be inherited by the idle state and the move state. So they'll just share the same Blackboard unless you overwrite them with their own Blackboard plan. But here I want to manage this and I'll add in a variable. I'll just say direction of type vector2, the direction the character is trying to move. So if I hit OK there, then that basically puts in the property that this is automatically creating. So if I want, I can change this to false now, and then it will automatically create that variable. In fact, I think it might error out if we don't have this, but we should be able to hit play and it should still work fine. Okay, now on our root script, the Captain Clown knows, we no longer need to get this direction. What we need to do is just cut this out and we'll take the velocity setting in the move and slide and we'll put that out to our character states. So I'm going to open up the idle state here and I'm going to go deeper into the character state, right click lookup symbol, and I'm going to create a function here called move. And this can, let's say, return the velocity or something. So I'll just say returns a vector2 with the arrow here. And we're going to take the direction and we're going to use that in order to determine how fast the character should move whenever we call this move function. I just want this to be able to be shared by all of the character states if they are going to allow movement. So the idle can call this and the move can call this. And so we just put that one layer up on character state. Okay, so first we need to grab the direction from the Blackboard. So var direction is going to be equal to blackboard.getVar. And remember, we have that bb names file. So bb names.direction. So we're sure that the name is the same because it's stored as that static variable. And once we have the direction, we can check if the direction is not 0, basically. So that's what this does. Checks that the input direction is not 0. Okay, so this is actually a vector here. We're going to want to change this bit a little bit. So we're going to want to make sure that the input.x is not 0. So instead of if direction, we'll say if, I'm going to type in approx here. Yeah, if 0 approx on the direction.x, so the x is a float of the vector, and we want to make sure this is not approximately 0. Then we're going to set the velocity x on the character body. So that's actually going to be the agent.velocity x. It's going to be equal to the direction times the player stats run speed. So we actually need to reference the stats of the character as well. So let's see, if I click on my root, I have the player stats here. So if I right click in here, it's just a resource. All of our characters are probably going to have a run speed and maybe even a jump velocity. So we can also make that a parent class of character stats if we want. So I might right click on characters, create a new script resource. I'll call it character stats. This will extend resource. And then I'll take run speed and put that here. Class name character stats. So if I use this as the parent class, then player stats can just inherit that. So let's go to player stats, and this will extend character stats now. And we no longer need run speed here because that's already set in character stats. Okay, so now go back to character state.gd. I know that was a bit of jumping around. And we should be able to get the character stats from the agent because we're going to say any of these characters actually have their own stats. So on enter, we'll say var character stats, saved up here, and then we'll say character stats equals agent.stats. Okay, so we get the character stats and save it there. And now we can reference that down here. So we'll say character stats.run speed, and then character stats.run speed as well for down there. And then this just needs to be agent.velocityx. So remember, in the limbo state, this is the logic that is going to control character, but the character is still that character body 2D, which we're using as the agent. If you wanted, if it actually makes it a little bit more clear as well, what you could do is say var character of type character body 2D, and just whenever these scripts are entered, we can do character equals agent as character body 2D. It technically automatically already converts, but I think this just makes it a little bit more clear what's happening. So casting the agent as a character body 2D, and then from there, when you do, let's say, character.velocity, you'd actually be able to see all of the properties that a character body 2D would have. Otherwise, we're just kind of assuming here that the agent is a character body 2D. And while that will technically work, maybe it's a little bit more clear if it's like this, character.velocity.x. Okay, and then here we want to change direction to direction.x. Remember, we're working with a vector2 now, not the float that is just x. And over here, let's see, velocity is not defined in the scope, so we need the character dot velocity. So we need the character dot velocity dot x. So we're taking the character's velocity, we're making it approach 0, and we're using the run speed to determine how much we move towards that 0 from the current velocity. Okay, and then it's not the script that's move and sliding, it's the character body. So character dot move and slide. And that is basically going to be our move function. The last thing we need to do is return the current velocity. So return character.velocity. And now we have the ability to do ground movement from any character state. Okay, so stop the current execution. Okay, so we can take this function now, go into the idle state. And what we're going to say here is var underscore update. So instead of process, our state is going to use update, which is specific to the limbo states. Update only runs when the state machine is in the current state. So var update, and we're going to say var velocity is equal to move. And remember that turns the velocity after the move and slide. We can say that this is a vector2, which it's already implied that it is. So when we get the velocity after trying to move the character, if the velocity is 0, we don't want it to change state. But if it is moving, so we'll say if not, vector2.0 is equal approximately to the velocity, as long as the current velocity is not approximately 0. Then we'll send an event out to let the state machine know to switch states to the move state. So we can do that with the dispatch function. So dispatch, and I'm going to say moving in quotes here. You can pass in cargo to that event. So any data you might want the receiving state to know about based on this event change, you can pass that in. So I can send the velocity if I want. It's not really needed here, but you can do that. So we dispatch this. It's going to go up to the state machine. And then the state machine is going to determine what the next action should be. Now, right now, if we look at our state machine script, there's actually nothing here to create a transition between idle and move. So first, what I'm going to do up here is I'm going to create a dictionary. So var states dictionary, and this is going to connect a string name with the limbo state that it's actually trying to change. And then from that, I'm going to create a function. I'm going to call it binding setup. I underscored it to make it private, indicating it really is only used internally inside of this script. I'm going to add a transition from the state that's sending the event. So that's going to be states, and let's say in quotation mark, idle, to transition to states move. when the moving event happens. So the event name is moving. Okay, now I click on this state machine. We have this dictionary to set up, and I want to put in the states and connect them to the limbo state. So the name, idle, we'll assign that to idle. Add key value pair. Next, move, and we'll assign that to the move state. Okay, so when it says states and then in quotations, idle here, that means it's going to get the key, which is a string defined up here, as in the idle string, and that connects us with the idle state. So this bit right here is actually getting the state itself, the limbo state, the idle state. And then we're transitioning from idle to the move state, indicated by this key move. So I just think that's like a pretty clean way of having a reference to all of your states inside of a dictionary, and then being able to use them down here for binding everything up. So we also want to be able to go from moving to idle. So might as well add that transition now. So add transition, and we'll say states move, and then we're connecting that to states idle, and the event will say stopped, as in the character stopped moving. So we should be able to go into the move state now, but not back to idle. So let's hit play. Okay, looks like, oh, we have to remove that logic from the player character body 2D. So we're not actually moving here anymore. It's the state itself which is handling that. So make sure you remove that from your physics process on the root script. We're trying to break everything out from this logic into the state machine so that not everything's being controlled by one script. The state machine breaks apart your logic into different states so that each state can handle what should happen during that state. Okay, now hit play. And still got an error. Let me see here. Character stats equal agent stats. Okay, let me see here. So it's called player stats up here in the root script. So like, yeah, if you try to assign something that doesn't exist there, you're going to get an error. So I might just go up here and rename this to be stats. Okay, and then we just need stats.jump velocity down here. Reassign the player stats. So quick load, player stats. And now when it's grabbing it inside of the character state, it should be able to see that. We could say character.stats here. Eventually we might actually create a character class which extends character body 2D. And then that has it hard defined that it will have like stats and other properties. So if we hit play now, it should work fine. I'm going to WASD to move around. So we can see it's not actually switching states as far as we can tell. So let me check the errors. In idle state, let me see if this is actually dispatching. I'm going to set a breakpoint here and let's hit play and move around. Okay, so this is actually dispatching. So we hit play. I jump into the state machine. Oh, it's because I never called binding setup. So on ready, we want to bind the setup, obviously. So underscore binding setup, have this code actually execute. And then we'll hit play and WASD. So the breakpoint was hit. I'll hit play, and we can see that we get to the move state. And from the move state, we can't do anything because the move state doesn't actually have code yet. So just like with the idle state, I kind of want to copy this over to the move state script. So what I'm going to want to do here is say that if vector2.0 is equal to the velocity, so I'm going to get rid of this not, then I want to emit the stopped event. And then that will go back up to the state machine, where based on this transition, we can go back to idle. Okay, and also, obviously very important here, the update actually calls the move. So I'll hit play, WASD to move, and now we are switching between idle state, move state, and the animation switch whenever those actually enter. So that is handling the logic for idle to move state for our state machine. And as our character grows in complexity, has more states, some which will be able to move and some which won't, separating everything out into states will just make your life a lot easier, especially for these kind of platformer characters. So that's going to be it for this tutorial. I hope that has been a decent intro into hierarchical state machines, especially with LimboAI specifically. And then after that, we will get to the behavior trees for the enemy, which will look quite a bit different simply because those are going to control logic not through player input, but through decision-making code that you write for the behavior tree. So remember, you can get the files for this project in the description below, Ko-Fi and Patreon. I've been Chris. Thanks for watching, and I will see you guys in the next video. Hello everybody, Chris here, and in this video we're going to be moving the jump code from the base script on the character body 2D of Captain Clown Nose up here into the idle and move states so that the character can jump from the ground and have that movement be controlled by the state machine, the Limbo HSM, instead. So as a natural kind of result of that, we're going to see that both idle and move are going to basically have the same duplicate code for everything. Being able to jump from idle or move, or later we might put in being able to do a ground attack from idle or move. And I think the result of that is that we'll see idle and move more as a combined ground state, rather than separating the code into both idle and move if they both essentially do the same thing, minus playing the animation of idle or run. So we can combine this into a ground state and just have the ground state control if it's playing idle or move, depending on if the velocity is not 0. But let's go ahead and start first with moving the jump code over. So if we open up the character body 2D script, we'll see that jump is basically handled here as a import. So whenever player actions.jump, which is spacebar currently, is pressed and the character's on the floor, then we'll do a ground jump by setting the velocity one time to the negative jump velocity. So as per the previous video, we were handling our input and player input, so that's where we're going to want to start. So I will just copy this bit over to player input. So let's actually try this time using the import function so that we don't have to run that code on process 4, just waiting for the jump key to be pressed. So let's do function underscore, let's say, input, but instead of using base input, we'll use unhandled input, which means that if the space key event of jump is handled by something else in the UI first, we don't want two things to trigger. So unhandled input would mean that only if it hasn't been handled by something else that we actually run this input event on this code here. So this is the line we have copied over from the other script. I'll make that a little different. We'll say if event.isAction pressed, and we're going to need player actions.jump, which is already located up here, the resource which stores the string names for the action. Then we're going to set the jump variable to true. So let's create a jump variable, jump, which is a Boolean. So we'll say jump equals true. And then we can also say else if event.isAction released player actions.jump, then we'll say jump equals false. So this means that as long as we're holding the spacebar down, the character is going to keep trying to jump, which for now is okay. We can always kind of modify this and tweak it a little later, but we'll start with that. And then we don't need this bit. The is on floor is actually going to come from basically being in the ground state already. So we might not even need to check is on floor, because if the character's in the ground state, then it's already implied that the character's on the floor. So let's cut that. We're not going to need it. And the last thing we need to do over here is to bind the jump variable to the variable on the blackboard. So just like up here, we're going to basically copy this, paste it down there. So we need a jump var, bbnames.jump var. And if I look up the old symbols, we'll just see that this is just a script that contains static variable names. So static var jump var, the string name. What do we want jump to be referred to on the blackboard? So I'm just going to put in quotations, jump. And once again, the point of this script is just to be a globally accessible list of string names to share naming consistency across the game project. Basically, write the string out once and use the same name across all of our different scripts by referring to the variable rather than hard typing in the string. Okay, so let's go back to player input, I think it was. We have the jump var set. So this is the name of the variable on the blackboard. And we are binding it to this object, the player input. So we're going to need the property name here. So just copy that, go into here for the quotes, paste it in. And this last parameter is whether it will automatically create the variable or not. So I want that set to false. And actually to test that, I want to hit play and see if we get any errors when I hit space or anything. It's still jumping. I think that's because on the base script, we still have this bit. So I'm actually going to cut that out of the root character body script, we can see that we're basically breaking apart this entire script into separate components. So in the end, this is just going to be basically a list of resources that are attached to the character. Okay, so let's check the errors. Blackboard can't bind the variable that doesn't exist. Yeah, okay, so that's kind of what we want to see, because we want to make sure that the Blackboard has everything we need. And in this case, it's just telling us that we've never created the variable. So on the Limbo HSM node, we have the Blackboard plan. We just need to hit manage, add a new variable, give it the same name as BB names has, so jump. And then this is a Boolean. And for hint string, I'll say whether the character is trying to jump or not. And hit OK. And now we can hit play. We shouldn't get that error message. We can press space. We're not really going to see anything happening because we have nothing to trigger off of that Blackboard code. Okay, but the main error message has gone away. The other thing we're seeing here, these warnings are just saying that we're not using delta, so we should underscore it to imply that it's not used for anything. So you can just add an underscore, go to the next script that it mentions, underscore that, and the third script, underscore it, hit clear, hit play, and that should be it. Okay, so now this should be setting the Blackboard property. So now on our idle or move state, or eventually ground state, we just need to read if jump is being pressed. And if so, then we need to actually make the character jump. So I'll jump into the move state script for now. Let's create a function jump. And this is going to take the character body, which on the character state script this is extending, is already set to character body 2D. And we're going to say that the velocity.y is going to be equal to negative. Let's see if we still have the stats. I'm going to right click on character state, character stats here, right? Okay. So back on move state, negative character stats dot jump speed or jump velocity. And that'll pretty much be it. Now, character stats doesn't have a jump velocity. If we look at the clown nose script, then we'll see player stats here is actually where jump velocity is being stored. So I think what we'll do, at least for this project, is just to say that every character can define a jump velocity, whether they'll use it or not. So we'll just move this up to character stats. We'll have jump velocity there and just paste that in there. So now we can grab this property in our move state, and it should be able to do negative character stats.jump velocity. To kind of confirm that, you can just move the property and then add it back in. So now that it's in the character stats, it's going to show up here. And that should work fine. So now we just need the condition for when we are going to jump. Okay, so to actually make the character jump, probably the quickest way to do that would be to do, let's say, if blackboard.getVar, we'll say bbnames.jumpVar. So just reusing the string name there. And this should be, let's just say that there is no default value. We expect there to be a false or a true set on the Blackboard. So if that is true, then we're going to run jump. Okay, so when we do this, this is actually going to run a whole bunch of times, I think. So let's hit play and try it out. So in move state, I'll hit space. But if I like hold the space bar, you'll see that the character doesn't go down because we're allowing it to keep running jump as long as jump keeps being pressed. So there's a few different checks we could make on the character to ensure that it can actually jump still. We only want it to jump once off the ground. So we could say something like blackboard.setVar, and we're going to say ppnames.jumps, and this is going to be able to imply how many jumps have already been made since a reset. So let's get a value. Current jumps is going to be equal to blackboard.getVar bbnames.jumpsVar. And yeah, we expect that to be an integer. So we're going to set the new value to jumps plus 1. So if the character has 0 jumps, we're going to make it 1 jump. So let's jump into bbnames and just add that variable, static var. And we could give it something a little bit more descriptive. So maybe something like jumps made var. String name is going to be equal to jumps made. Just because jump and jumps are so close together that it might get kind of confusing, but this is more clear, I think. So we'll go back to the move state and change that property name to bbnames.jumpsMadeFar. Okay, so that will increase the jump counter by 1, essentially. So what we want to do is we want to make sure that the jumps counter is actually 0. So let's put in here, if the character is currently trying to jump, then we'll do the extra check. So if the character is trying to jump, let's check if the character has 0 jumps currently made. So let's try up here, making sure that the character is on the ground. So if character that is on floor, just a convenient method of character body 2D. We can do that, and that's probably enough, but if we need to go extra, we could also add in and blackboard.getVar bbnames.jumpsMadeVar is equal to 0. So what this means is we haven't made any jumps, and the character is on the floor. Okay, so if we hit play and we move, well, let's see. We haven't actually added in the jumps made far. So that's a problem. Let's add that to the Blackboard plan. So add jumps made, and this will be a vector2. So obviously with this Blackboard plan, we could just have those individual states creating the needed variables on the Blackboard internally on the script. But I think having them typed out like this makes it a bit more visual and easy to understand like what is actually required for the character to run here. So that's kind of why I'm manually creating it rather than just setting true on the binding. Anyway, let's hit play again and move, and then we can get the jump. So let's see. Okay, and the jump's made, of course, that should be an integer, not a vector. So let's hit play, and I'll try to jump. So in move state, we can make that jump. But if I try to hit space again, it's not going to work because we don't have any reset on the jumps made here. So that would require some kind of landing scenario. And of course, we can put that into the move state or a ground state, but we see now that the code is kind of starting to pile up for the move state. So what I really want to do is just combine move and idle into one script. So let's say that in the players folder, we'll just right click, create a script here and call this ground state. And then basically all of this code I'm going to put over to ground state. This is going to extend character state up there at the top. Okay, and now, and so aside from that, it's just copy and pasted from what we had in ground state. Instead of dispatching an event, we're just going to handle the animations internally here. So I'm going to say when the character stops moving, character.sprite.play, and that's going to play the idle animation. So we can set a variable for that up here at the top. Export var idle anim, which is a string name, and we'll default that to idle, but obviously the actual name is idle s with a capital I and an s and a space in between. So I'll update that in the inspector. And then we need export var move animation, which is string name, and let's put in move there. So if the velocity is 0, we're going to play idle animation. Otherwise, we're going to play character.sprite.play move animation. Okay, and really, that right there is just combining idle and move into a single state now. So I'm going to take ground state, move this script up to move state. I'm going to rename this to be ground state. Let's just get rid of the idle state altogether. And because we combine them into one state, we can go up here to the HSM and we can remove these bindings. We are still going to use bindings in the project, of course, but not needed for the ground state because that handles both animations. So we're just going to put pass here for now. Still call it in ready, just so we're ready to actually use this again when we add in like air states and such. Okay, and let's see where we're at. So I'm going to hit play here. We can move. We can jump, so that's working, but the animation switching is not. So, okay, so as I mentioned, we have to get the animation names right. So in ground state, for me, and if I I can check the animated sprite to see this. It's idle S and run S. So ground state, I need to rename this to idle S and move S. Okay, if we hit play now, let's see, there is, oh wait, it's run S, sorry. So run S, and the default animation, actually, let's make that idle S, hit play. Okay, now we can see that we have one state, but it is going back and forth between idle and move. So one state handles two animations. Okay, so I think now we want to add in an air state so that when we are in the air, we can move around a little bit differently than we're on the ground. So first off, I'm going to take the move from character state and put that into ground state, because if I look up the symbol, this move is really running around on the ground. So I could just say movement for running on the ground when free to do so. Okay. And then I'm going to cut this and put it over there on the ground state. So this is really the ground move. Alternatively, you could put in a bunch of parameters like, okay, which variable are you actually using to determine how fast it moves in the air? But if you think that it's going to be different enough, you can just create a totally separate movement for air state. Okay, so let's create a new state in Limbo HSM, right-click Add Child Node, and I'll just type in state here. This is going to be a character state. Then I'll rename this with F2, air state, right-click, extend script to airstate.gd. By the way, while we're doing this, since I showed you kind of how idle and move state have just been superseded by this ground state, you can just take the idle state and the move state and delete those if you like. You can leave them there just in case you need to go back to them, but I'm pretty much sure I'm going to be done with it, so no need. So in the air state, just for right now, we'll just say that you can't move in the air. It's just going to basically move out however the velocity is going based on the character physics. That's it for right now, and then maybe we can add in an air move in a second. But let's go into the ground state and add in a transition from ground to air. So this is going to happen when the character is jumping or when the character falls off of basically the edge. So what we could do is actually take this is character on the floor, kind of move this out a bit. So if character's on the floor, then we'll allow it the option to jump. We'll still have those conditions there. But if the character is not on the floor, we want to immediately switch to the air state because it's in the air, of course. So we'll say else, and then we'll do a dispatch here. The event will be, we could call it like in air. Yeah, sure. And that's all we really need there. So we just need to take this event name to the state machine. We'll do the binding setup. So add transition, and we'll say states ground to states air, and the event is in air. We could also add in here another transition, which is going to be states air to states ground, which will be the event on ground, which we haven't set up yet, but we will soon. And I think the last thing we need to do there is to customize our states here. So in the Limbo HSM, we have this states dictionary. We need to edit these. So let's get rid of these two and add a new one. I'm going to say ground with the value of ground state, add key pair. That's our default state. And then we have the air state, which is going to assign the air state node. So add that in. And this will make it so that we can transition at least from ground to air for now. So if we hit play, we can see the characters in the air state, which is unexpected. So if the character's on the floor, we allow it to do this. Otherwise, we dispatch in air. So let's test if that's actually happening. Hit play. Okay, yeah, the character's being shown in the air. So let me see here. That could just be because at the initial starting frame, maybe it hasn't detected the floor yet. So let's also add in the transition for air state to ground, because it should be able to immediately switch back to ground. Okay, so in air state, we'll say function update. And if the character that is on floor, then we're going to dispatch the on ground event. So let's see what happens with that. Okay, so let's hit play here. We can see dispatch in air is still occurring. Okay, so for the character body on that first frame, what we're checking is on floor, it just seems to not get that gravity collision yet, even though we're applying the gravity here and calling move and slide. So if that becomes a problem, we could just have a like a check, like if it's not on the first frame since entering, then we won't make the switch. Yeah, okay, why don't we just do that here? So var underscore on first frame equals true whenever we enter. We'll say on first frame equals true. And then down here, we only want to dispatch an error if we're not on the first frame. So else if on first frame, let's say else if not on first frame, then we can dispatch. And then on exit, so we could do like function exit here, and then on first, oh wait, not on exit, sorry. At the end of our first frame, then we will say on first frame equals false. So that's kind of a workaround just on how the character body 2D seems to be handling that first collision, that first frame collision. So this first frame check here is just a lock to prevent switching to air before the character body has a chance to detect the first frame collision. So with that, we should not get dispatch air when we start on ground. Okay, and something we're going to have to be a little careful about when we're overriding the enter function here. We also have an enter function on the character state. So this bit about getting the character won't run unless we call the super function on the child state. So on ground state here, we want to call super here. So this means that we go up to character state and we run this code before we run the ground state's enter function here as well. So that's one of the things where you inherit too many classes on top of each other. It can get a little confusing because you might accidentally be ignoring one of the functions that's supposed to run. So be aware of that. If you need to call the parents function, use super. Okay, now if we hit play, we should be on ground state to start. If I hit space, we get the dispatch error because we're not on the first frame. We go to air. We're in air. Now physics isn't really running here because we need to be calling move and slide. I'm going to be doing character.move and slide. Eventually we'll turn that into the air movement. So let's hit space. We hit left click on the window, space to jump, and we have our jump added back in. Now we're not able to jump again, probably because we haven't reset the jump counter, but we were able to go from ground to air and back to ground, which is good. So on re-entering the ground state, or whenever we enter here, we actually want to set the jumps variable to 0. So we'll say blackboard.setVar bb.bbnames.jumpsMadeVar. And we're going to set that to 0 whenever we enter. So we hit play, we click on the window, jump, we go to ground, we can jump. And as you can see, based on the direction that I'm traveling when I leave the ground state, it's going to keep moving in that direction. It's just applying the gravity, and that's really it. Now, if you actually make a character like this, I mean, you can do it, but you're going to have a lot of going off the cliffs and not being able to backtrack or do anything about that, which is, you know, pretty realistic, I guess, in a sense, but really hard to control in terms of game mechanics. So what you might want to do is go back into your air state, and we'll take this move and slide and we'll do a air move. So function air move, character move and slide, we'll paste that in there. And then we need like a air speed. Probably you want that to be different than the run speed. So let's look up character stats in our scripts. I'll go into character stats, we'll add in here export var airspeed, and let's make that default to something probably slower, like 150, maybe. We'll see how that works. I'm probably going to need to turn this into like an acceleration, not just setting the value. So let's go back to ground state. We'll go down here. We'll grab this bit, back to air state for the air move. And let's paste that in there. So the air move, we're going to get the direction based on the user input. And if it's not 0, then we're going to set the velocity equal to that. But that's going to be basically whatever the airspeed is, it immediately becomes the airspeed. So there's no acceleration or deceleration. Or I guess here's deceleration of a sense. But it's going to require some tweaking to get this to work. So first off, change character stats.run speed to airspeed, so that we're working on a different variable there. And if we want, we can return the speed or the velocity. So we'll say return character.velocity here if we like. And let's hit play and see how that's working. So we get into the air, and you can see we can move in the air. But if we jump into the air, you'll also see that it immediately stops whatever movement we had from the ground, which is kind of wonky. So actually, if the direction is 0, I don't want it to move towards 0. There shouldn't be any friction. So I'll cut that out and save, and let's go run. So I'll jump, and now you'll see that when we don't press anything, we're just basically using the last input in order to determine which direction we move. We can change it so that we do have that air move, but it's immediately slowing us down from the ground run speed into our air speed, which isn't exactly what we want. So in character stats, we'll also want like a export var air acceleration, which would be a float. Let's just set it to 100 for now. Okay, and I'm going to start by getting the current velocity here. So var velocity equals character.velocity. We'll just get the current velocity. So var current velocity is equal to that. So we only want to decelerate if the direction we're trying to go is the opposite of the current velocity. So for instance, if the character is already moving, let's say velocity of 300 to the right, we don't want to slow it down to 150 to the right if we are pressing the right input. Okay, so if the direction is greater than 0, then we're trying to move to the right. Then we'll say the character.velocity.x is going to be equal to the maximum between these two numbers. So the current velocity.x and something like an attempted velocity. So var attempted velocity is going to be equal to the character.velocity.x plus character stats.air acceleration. But that's going to be the min of the airspeed or whatever this becomes. So let's see, min character stats.airspeed and this. Okay, so let me explain here. Okay, and this should be direction.x up there. Okay, so if the direction x is moving to the right. Okay, so we want the lower of two values, hence the min function, of the airspeed. That's our airspeed cap speed when we're trying to move to the airspeed. That's as fast as we can go when our character is accelerating in the air, so to speak. And we are taking the velocity x, the current velocity. Yeah, and that should be like this up here. Yeah, you know what? Actually saying current velocity is kind of redundant. Let's remove that bit right there and just say character.velocity.x. And down here as well, right. Okay, so this value is taking the acceleration and adding it to the current velocity, right? But our acceleration is capped out by our max airspeed. We could actually rename this to be max airspeed. That might help a little bit. So I'll right-click, look up the symbol or character stats. Let's say max airspeed. Okay, now we'll go back to the air state, and it's going to give us some errors. So we rename character stats.airspeed to max airspeed. Okay, so this is our cap, and this is how much we're trying to accelerate to before applying the cap. So we apply the cap with the min function, and that's our attempted velocity x. So from there, we're going to put this into here, and let me add some comments to kind of help this. So this is the acceleration capped by max airspeed, and this is taking the higher of the current value or the attempted velocity x. So if we launch our character into the air, and it's already traveling faster than our max airspeed, then we're going to keep going at that current value. So we can slow down the character to a lower value, and we can control the character manually between the max airspeed and negative max airspeed. But if we are launched at a super high speed, then we are only going to be able to decelerate from that very high speed. Yeah, hopefully that kind of makes some sense. And we may have to tweak this, but let's see. Is there a way we can do positive and negative in one go here? Not off the top of my head. So I will say, else if the direction.x is less than 0, then we're just going to take this and invert it. Okay, so this is going to be the max, and then this is going to be the min. Okay, because here we're looking for a number closer to 0, and then here we're looking for one that's further away from 0 to the negative. Okay, so the attempted velocity x, we're going to subtract the air acceleration here instead of adding it. And this is going to be actually the negative max airspeed. I could say -1 times if that makes it a little more clear. And down here we have the attempted velocity x. So if the current velocity is lower, as in to the left, more negative than the attempted velocity x, then we're going to take that. Okay, and then I think we don't need this bit right here. And this would be acceleration slash deceleration hit by max airspeed. Okay, yeah, hopefully that roughly makes sense. So let me hit play and I'll give it a shot. We'll jump into the air. Okay, so you can see that when we have that fast speed, we are still maintaining it. So I can slow down by going to the left, but if I keep pressing to the right, I'm not actually making it go faster than it already is, but I'm also not making it go slower. So when I'm going very fast to the right, I can only decelerate by pushing to the left, and vice versa. So if I go very fast to the left and I press right, I'll decelerate, but I'm not going to ever get back to those very high speeds of the ground launch, so to speak. So that's one way you can set up your character. I'm kind of surprised that pretty much worked in one go. So now you would just want to tweak your values. So we could change the defaults here. Maybe it's like 200 for the max airspeed. And we could say the acceleration is maybe faster too. We could say like 200. So now it'll look more like this. If you want, you could also add back in kind of the natural move towards zero air friction of some kind. But that might be making it more complicated than it needs to be here. Okay, so our jumping's pretty much working. Our return to ground state is working. We could have like a landing animation if we wanted here as well. That is very much character dependent if you need that sort of thing. Last thing I want to do for this video is to put a facing direction kind of node so that we can flip our animated sprite depending on if we are facing to the left or the right. So I'm going to right click here, add a child node. Let's do a node 2D. I'll move that up here. I'm going to rename this to be facing. So I'll right click, add a script. This can go in character actually, because all characters should basically be able to face a direction. Let's create, and I'll rename this class name facing. And what I am going to want to do is on physics process, let's say, then we'll update the facing direction. And in this case, that's going to be the scale. So a scale of -1x is going to be facing to the left. And that's specifically scale.x. So on physics process, we are going to get the velocity. So if character.velocity.x is greater than 0, then we are going to take the scale.x and set that to 1.0. Else if the character.velocity.x is less than 0, then we're going to take the scale and set it to -1.0. Oh, and we need a reference to the character script or the character body. So let's do a export var character body 2D. Okay, and we assign it in the inspector, Captain Clown Nose, and that's basically going to be that. Oh, and for this to work, you actually need to take the nodes which need to be flipped and put them under facings. So that's going to be the animated sprite. I'll pop that in here, and we can hit play. So now if I do left-right, we have left-right movement because we're flipping the scale on the parent node of facing. And that is how you can make a character play one animation, but flip the node so it looks like it's playing it to the left when really it's just playing the same animation, but the node's flipped around. So that is a pretty thorough explanation of ground and air states, switching into jump modes, also adding in air acceleration and deceleration, which I didn't plan to go that in depth for it today, but hopefully, yeah, that bit of this code here about air acceleration and deceleration helps you guys out for creating a cool platformer character. So I guess the next video before we jump into the LimboAI for the enemy with the behavior tree is going to be to do a couple attacks on the character. So we'll add in like maybe a ground attack, and if there's an air attack, let me check if there is. Do we have an air throw or an air swing? Yeah, okay, actually he does have that. It's cool. So we can add in like a ground attack state and an air attack state where it'll play those animations, and we can have them hit the enemies as needed. Okay, so that's going to be it for this video. I've been Chris. Once again, the project files are in the description if you want to check out the Ko-Fi and Patreon for supporters. Thanks for watching to the end, and I will see you in my future video content. So in the last video, we handled the ground and air states for our character. Now we'd like to add in a couple attacks. So attacks are going to work a little differently than the ground and air state in that a character that is attacking may not be able to freely move necessarily. And it's going to play an animation, and then when that animation is done, we automatically return to either the ground or air state, depending on if the attack is made on the ground or if it's in the air. I'll just start by adding in another state. Let's add in a character state, let's say. And then we'll say this is the ground attack. Okay, and we're looking for the animation attack 1, attack 2, attack 3. Okay, so I'll right click on ground attack. Let's extend the script. So this will be player ground attack. And if we look at the animated sprite, you see that there's 3 attacks here, right? So we want to be able to basically cycle between them or go from 1 to 2 to 3. And then if 3 is finished, we automatically go back to ground. But we would also want to be able to cancel out of attack 1, attack 2, and attack 3 if we decide not to press the attack key anymore. So we'll need to get the attack input from player input, and we'll need to check at the end of each animation if we should still continue the ground attack inside of the ground attack state. So I'm going to also put in here at export var attack 3, which would be a string name. Okay, so our first animation is, let's see, attack, or okay, attack space 1, right? So attack 1, attack 2, and attack 3 here. Okay, so let's take a look at the attack 1 animation. If I hit play, you'll see that there's a few frames here, and depending on the frame, it kind of appears like the collision shape should be changing on what the character can hit and what it can't. So we'll need a collision shape out here, and we'd want that to kind of adjust depending on the position where the sword is currently at during its swing. So I think a good way of handling that would actually be to include an animation player. Initially, I was trying to avoid the animation player to keep things as simple as possible, but in this case, the collisions are very much tied to the exact frame that we're at for the animations. So we can use an animation player with the animated sprite for another layer of basically power, but also complexity. So I'm going to right click on Captain Clown Nose. Let's add in an animation player. And then here I'm going to create some animations that are specific to the animation player. So let's add in a new animation. I'll say attack. Let's just call it attack 1, attack underscore 1. Then I want to add in the property tracks for, let's say, the animated sprite 2D. What animation are we playing on the frame? Well, we're going to play animation 1. Okay, so what I'm actually going to do here is add property track on the animated sprite 2D again, and we're going to do the frames. So we already have the frames assigned here in the animations. So what we just need to do here is we need to change the value of the property, and that's going to mean the key is the value of which frame we're currently playing. So make sure that this one's at 0, 0. Let's set up the frame snapping here to be to how fast we want the animation to play. I'll just do 0.1 for 10 frames per second. We change the first frame to 0 here. And then let's snap timeline cursor to 0.1, add in a frame, change this value to 1, and then 0.2, add this to 0.2. So if we hit play here, we can see our animation still plays, and we want to cut off the animation over here on the right to 0.3. So this should be a non-looping animation. Oh, and this frame needs to be 2. That's why it looks weird. Okay, so hit play. Yep, and there we have our attack finishing. Okay, so yeah, this is definitely an extra step above just playing the animation directly on the animated sprite 2D. Instead, what we'll have to do is play it on the animation player. But what this allows us to do also is to change other properties that are unrelated to the animated sprite 2D, like our collision shape. So let's add in to facing. I'll add in let's say an area 2D node. Let's call this sword. And then this is going to have a collision shape 2D. we can, well, let's see, what kind of shape is this? Probably something like I want to say like a capsule shape. And then let's move it over here. E to rotate, and I'm going to rotate it sideways, 90 degrees. Gonna shrink the sides, and something kind of like that, maybe a little bit wider, is probably appropriate for our sword. So I want to take this collision shape and I want to change its position and possibly its size, depending on what frame of the animation we're on. So let's see, I will keyframe it there for the position, and then we'll go to 0, 0, and I will keyframe its position over here. So you can press keyframe on the right, which adds a keyframe to the animation track. Okay, so rather than creating a different shape on every frame, what I'll do is I will just scale it down at the first frame. So let's do scale here, create, and then go down here, and we're gonna hit, let's see, I think it's Shifty, no, S, to scale it, and then scale this as well. Okay, and then at frame 0, we want to scale this down. So I'm going to, let's say, shrink. Yeah, let's just shrink it and keyframe that. So now at frame 0, it looks like this, and at frame 1, it's more like this. And then we can also maybe scale it up a bit on this frame. We can reposition it if we like to. So keyframe, keyframe. And now our attack is going to look something like this. Oh, and we don't want it to actually grow in size. We want it to just immediately jump. So you should change continuous over here to discrete. Okay, and this would be much more appropriate for our pixel art animation. So that would be our first attack. Now we also want to make sure that this is enabled. So I'm going to set disabled false as a keyframe here. But on the reset, we're going to want to actually take this and set it to true. So whenever we're done with the animation, we are going to turn off this collision shape altogether. So only when we start the attack is it going to have that collision. Okay, so that's our first animation. Let's duplicate this and we'll have an attack 2. So we just changed this animation to attack 2. I can check how many frames are in here. There's 3. So back to the animation player. We don't even need to change the frame number because it's already assigned here. So what we actually need to do is adjust our collision shapes again. So let's work on that. So frame 0, the collision shape, we'll just kind of pop it up here. Okay, and that can be our keyframe there. We jump to the next one. Okay, it looks pretty wide here, so I will make this much bigger, kind of like that. So keyframe, size, and position. And then we go to the last one. And here I think it's going to shrink down to something kind of like that. And keyframe. So we hit play. And that's our attack 2. Okay, so we can now duplicate this again and just do attack 3. Okay, let's change the animation to attack 3. Let's hit play. Okay, so we can see this one kind of goes outwards, right? So on the first frame, let's move our collision shape down to here, kind of a low attack. Keyframe, position, and scale. Next frame, we'll make it big again. Keyframe, position, and scale. And then up here, we will make it something like this. Just kind of where you imagine the sword to be. Obviously, the slash marks indicate that it's there, but the sword's over here. But it should be like, what do you think the sword should be hitting in that in between of the frame? So yeah, keyframe, the position, and scale, and that's basically it. Yeah. So there's our 3 attack animations. Now, if we're going to be using the animation player for everything at this point, which I think we are going to be, then we do need to add back in as well other animations. So we'll say idle s. Okay. And then we're going to need to add in the track of the animated sprite animation. Add that in here. So idle s. Then we need the frames, so add in the frames track. Okay, and just like before, we're just going to go like 0, 1, 2, 3, 4. You can even click on animated sprite, and I guess you can't do that with sprite. I guess you can't do that with animated sprite. Usually there would be keyframes over here for sprite 2D, but I guess they don't have that for animated sprite. Interesting. So we'll have to just manually go to 1, insert key, change the value to 1. Not too much more of a trouble, but just do this for every frame of the idle animation. And if you want to see the idle animation, just see here, there's 5 frames, so we need to do this 5 times. So this is 3, this is 4. We want looping enabled, make it just after the 5th frame ends, and then you can hit play, and that is playing our idle animation through the animation player. Okay, and then lastly we need 2 more, I guess. We need run s. Actually, I will duplicate this. That'll be quicker. Duplicate for run s, change the animation to run s, and let's see, is that all of the frames? Click on animated sprite 2D. Nope, we're missing one. So just have to insert another key here, frame 5, change the duration to 0.6, hit play. Okay, and there, I think that's our proper run animation. Remember though, on reset, this is supposed to be disabled. So if you ever, like your character's running and this isn't disabled for any reason, it might be accidentally hitting a target when it's just not supposed to be, because this is a run animation, not an attack. So just keep that in mind. Let's duplicate this one more time, and then we'll have the, well, I guess there's probably 2 animations. We have the rise and the fall, don't we? So there's our fall with sword. Where's our jump? Yeah, okay, so jump S and fall S. We need both of those. So duplicate this for jump S. Click here, and we'll change this to jump S. See how many frames we have in jump S, which is, right, I guess maybe we only need the first 2 frames, based on how I'm going to do it. So let's get rid of these extra keys, delete them. This would just be 0.2 and looping. Actually, not looping, just 0.2. So 0.2, yep. And then we're going to duplicate this, and we'll get our fall with sword, fall S. Change the animation to fall S. I'm going to see how many frames are in that. Fall S has 1 frame, so we do not need that second keyframe, and this can just be 0.1 seconds, looping, or not really necessarily needing to loop it. Okay, so those are all the animations we need so far. What we're going to want to do is to jump into character state, the base script, and instead of calling play on the sprite, we're going to call play on the animation player. So I'm going to take Captain Clown Nose. We can still leave the reference to sprite there if we want, but really what we need is the animation player here. I'll type animation player, and I'm going to assign the animation player here. So now in the character state script, we're going to be calling, well, let's say character dot animation player, and I think it has a play function, but let me check here. Animation player dot play, the name of the string. Okay, yeah, okay. So yeah, this should essentially work. Okay, so we're still playing the name by the animation, but I decided to make it snake case here for all the animation names. So we're playing the animation on the animation player, not the animation on the animated sprite. So those are 2 distinct things. Keep that in mind. So on ground state, we're going to enter onto idle underscore s. Our idle animation is idle underscore s, and our run is run underscore s. For air state, I guess that should be playing jump. Well, actually, that depends. Whether the character's falling or rising is going to determine whether it is playing that animation. So I might just leave this blank here. And then we go to ground attack, which is going to start with attack 1. It's going to go to attack 2 and attack 3. So that's lowercase attack underscore 1, 2, 3. And we'll get to that in a minute. So first off, let's just play and see if this is even working. So I don't see the animations play. We got a bunch of errors here. So let's see. There's no animation idle s. Oh, right. Okay, so the other scripts are playing on the sprite still. We want to change that to animation player, character.animation player, and let's check the other scripts. Okay, so I think it was just there for now. Let's run it. And okay, now we're playing the animations on the animation player. That's good. That's what we want. Can jump into this little warning on the facing node and just underscore that because we're not using the delta. Okay, and now in the air state, basically, whenever we update, we want to select the animation, and also on enter, we want to select the animation as well. So I'll make a function here, select animation. So if the character.velocity is greater or equal to 0, character.velocity.y is greater or equal to, oh wait, hold on. It's reversed in Godot, so actually up is negative. So if it's less than or equal to 0, then we're going to do character.animation player.play, and that's going to be our, that's actually going to be our rising animation. So let's export to string names here. Export var rising animation. String name, I'll just call it rising. And then at export var falling animation. String name is equal to falling. So we'll say rising animation. Otherwise, we're going to play falling animation. Okay, now what I mean by that when I say rising animation is if we look at the jump animation, I guess we have to play it on the animation player now that we have one. Okay, so jump animation, whenever we start moving up, we don't want to necessarily play jump. That's only when jump is actually pressed. So, so the jump animation is actually going to be a little different than the rising animation. So let's do rising. We could say rising S if we want. And then I'm going to delete the first frame and just put this here. Make the duration 0.1. Oh, I guess we need frame 2 here, huh? So let's delete the frames here. On frame this. Okay, so if it's not letting you change these values, you can go to the animated sprite and just make sure this is stopped if you need to. But let's delete the frame there. We need to go to the start here and add in frame 2, duration 0.1, and hit play. Okay, so when it's rising, it's just going to play that. When it's falling, it's just going to play that, just a single frame. But when we jump, we play that little animation there to indicate, oh, we pressed jump. So, okay, well, first off, we'll start with this. We'll just have the select animation there. Let's call select animation. But this is only going to work for rising and falling, so we're not going to have the jump animation. So let's hit play. We get up here, and it doesn't find those because I forgot the underscore S. Underscore S is for sword, I guess, for that character. So we jump, we have our rising animation, and then falling. But it's not playing falling because falling S doesn't exist. So you just have to be careful about those names. So it's fall underscore S. Okay. So air state, fall underscore S, hit play. Okay, there we go. We have our rising and we have our falling, but we don't have our jump. So what we could do, let's say that when we jump, we dispatch a jump event. Dispatch jump. Okay, and then on the state machine, we add a transition, add transition states ground to states air, and we'll say jump. So when jump's pressed, we enter through the jump transition. So let's say that when we're in the air state, we have a jump lock. So if a jump animation is playing, then we will not do the select animation. So in here, var jump lock, we'll default that to false. But let's add in a setup. Function underscore setup, we're going to add a event handler. The event is jump, and the handler is on jump. Okay, so we need to put in that function down here, the function on jump. And this is where an events cargo would go as a parameter if you have any, but I didn't add one for transitioning here by jump. So when we jump, I'm going to add in the jump lock. So jump lock equals true. And I'll say for select animation that if jump lock, then we just return. So we can't choose a new animation until the jump lock is released. And we're going to release the jump lock when the animation is done playing. So to do that, we want to connect with the animation player on the character. So character.animation player. And you know what? So the character is a character body 2D right now. But I think we could start just calling this a character script. So in here, where we have a player, I'm going to have that extend character, which is a new class we'll just create right now. So let's create character, which extends character body 2D. Create. Okay, and this class will be named character. So if we jump to the player script, this extends character now. And then we'll move, let's say sprite and animation player, and maybe even player stats to that script. So character, it's going to have all of these. This will just be of type character stats because we don't know it's a player yet. And animation player and sprite. So okay, so now we need to click on the player script and assign those again. Okay, just over here on the right, and we'll quick load the player stats. So you can see here, player stats extends character stats, so it's an option here to select that. And now, because we know this is a character script, we can go to the character state script, look up symbol, and we're going to change this to character and agent as character. What that means is that now we can do something like character.animationPlayer, and we'll see that pop up because that is a property that is officially on the character class. So now we jump back up to the air state, and we can do like character.animationPlayer, and we'll be able to easily see the properties that are on here, such as .animation finished. And we're going to want to connect to the animation player on that for on animation finished. So let's do that. Function on animation finished. So we're going to get the p animation string name. So if the animation that was just finished is the jump animation, then we're going to release the jump lock. Okay, let's take this up to the top. P animation equals jump animation. So we might need to add that in. Jump animation, string name equals jump. But I happen to know that it is jump with the underscore s. So yeah, when jump s is done, then we can release that lock. Yeah, I think a better way of doing this actually, this would work, but let me try something else. I'll create a function here called release jump lock. Okay, while I'm pretty sure this would work, I actually have a better way of doing it. So for jump s, let's right click here. Let's add a track here. And this is going to be a property track on the air state. We're going to take air state dot. Okay, so while this would work, I actually have another idea. So why don't we, in character state, let's create two functions. One, lock animation. And then this is going to say animation lock equals true. And then function unlock animation. And we'll say animation lock equals false. And then we'll have bar animation lock here, which is going to default. It'll be a Boolean, but it defaults to false. Okay, now that we have that, on our animation player window, we can add a property track to the air state. And, oh, not a property track, a call method track on air state. And we're going to call here, we're going to call lock animation. And then when the animation is done, we're going to call unlock animation. So this is going to mean that during this animation, other parts of the air state can't interrupt it. So we don't need the jump lock. We don't need to connect to animation finished. We just need to check if animation lock. Then we return here, and down here we can get rid of that as well. Yeah, maybe we don't even need the setup function. maybe we just go to the ground state, and when we call jump, we're just going to set the animation player to play jump. So character dot animation player dot play. This is going to be the jump animation. So let's add that up here at export var jump animation string name equals jump. Put that down here, play the jump animation name. And then we just need to make sure that this is correct. So it's called jump S on the animation player. Let's do that. And let's give it a shot. So I'm going to hit play. Let's see, character stats, run speed. Okay, so right now it's not getting the character stats. So let me see here. If we look up the symbol, character stats equals character.stats. And actually, we don't even really need a separate variable here. Character already has character stats. So let's just erase that. Let's go to ground state and clean up a bit. So yeah, anywhere that we need character stats, we're going to need to replace this with character.stats. So by the way, how I'm doing that is you select it, you hit Control R, and this is what we're replacing, and this is what we're replacing with. So replace all. And this means we're going onto the character object, we're finding its stats property, and we're getting the run speed off of that. Then likewise in air state, we're going to need the same thing. Find characters underscore stats and replace it with character dot stats. And just replace all. Let's check the ground attack, nothing in there. Okay, so if we hit play, let's give that another shot. So still can't find the character dot stats. So let's see why not. We have character here and stats is null. So if we click here, we can see that it's assigned, but I bet if we check the level, then for whatever reason, it's not defaulting to its default. So we have to reset that there. Okay, let's hit play. Let's hit space. Okay, we saw we had the jump animation there. And then after the jump is done, we just played the rising animation and the falling animation. And to prove that that's actually working, let's go into the air state and I'll put a keyframe here and one here and one here. I'll hit play. Let's jump. Okay, we see the animation lock is currently active as per the jump animation because we're calling lock animation. Hit play. And after a couple frames, we get rising animation to play as it's released, but we're still going in a negative Y direction, which is up. And then we hit play and we go to falling animation. So it's working perfectly, and we didn't even need the signal on the animation player because we're just calling it from within our animation. So now you can do a similar setup for anything else, like a ground attack. So we'll probably do that as well. Oh, we actually probably don't need to because we don't have a select animation for the ground attack. Let's go into our ground attack and actually make that work. Okay, so first off, let's get the first animation to play. So we need in player input, we'll jump into player actions here, right click, look up symbol. We'll need an attack button. So at export var attack, which is a string name, and we'll just put it generically as attack. So now we need this action added to project settings and put map add action attack. For attack, I'll just say left mouse button for me. Yep, sure, and hit close. It can be whatever key or input you want, really. Okay, so when we press attack, so we'll come down here to unhandled input. If event that is action pressed attack. Oh wait, player actions dot attack. Oh, that's the whole point of the player action script, is avoiding hard coding the strings. Then we'll say attack is true. But we'll say else if event dot is action released player actions dot attack. Then we'll say attack equals false. And then we'll just have to bind that to the blackboard as well. So var attack is a Boolean. We're going to bind it on the blackboard. So bb names dot attack var, and that's going to be connected to self attack, and we're not going to create the property. So let's jump into bb names, right click, look up symbol, and let's make static var control v paste attack var string name is equal to attack. Okay, Now on our blackboard, we add in the attack. So add variable attack, which is a Boolean, whether the character is trying to attack currently, and close that. Okay, so we want to be able to transition from ground to ground attack if attack is pressed. So let's go into ground state. And we could say something like if blackboard.getVar bbnames.attackVar. So if that's true, then we'll dispatch an attack event. Okay, and then from that attack event, we jump to the state machine script. We want to bind it to the ground attack. So transitions states ground to states attack. And this will be the attack event. So just make sure that that state is added in here as well. So let's add in the attack state, assign it to the state the ground attack node. And that should allow us to enter this, I think. So let's hit play. I'm going to left click. There we get our ground attack, just like that. Okay, so now if we're still pressing attack on the end of our attack animation, then I want to transition to attack 2, attack 3, and then after attack 3 is done, I always want to return to the ground state. So let's say function setup. Actually, let's say function enter. Because I only want these to really be triggering while we're in the ground state. So say character.animation_player.animation_finished.connect, and we'll say on animation finished. And then on function exit, we'll just disconnect that. So copy all this, paste it down there, change connect to disconnect. And then enter also needs to be calling the super. So super there to make sure it still calls character state enter. We don't have one set up for exit yet, so we don't need that. And then we need the animation finished callback. So this is going to be the animation string name. So if the animation equals animation name, then we're going to call character animation player dot play attack 2, else if the animation, oh, we could really make this a match statement actually. So match p animation, and this is going to be if it's animation name, then we play this. If it is attack 2, then we're going to play attack 3. And the default, any other cases, is that we're going to dispatch the, let's see, I guess like attack finished. Or let's just call this the finished event. So also, we only want that to be occurring if the blackboard still has the attack Boolean set to true. So if not blackboard.getVar bbnames.attackVar, then we're just going to dispatch finished, and we're going to return. Okay, so that should allow us to have our attack chains, and we'll give that a shot. So I'm going to hit play. I'm going to hold down left click, and then we get 3 attacks. Now the dispatch finished isn't doing anything yet, so let's go back to add transitions. Let's add a transition from states attack to states ground, and that's going to be on finished. Now let's hit play. I'm going to hold down left mouse button, and you can see we keep going between our different attacks. Now there's no cooldown on how long it takes to enter the ground attack, but it's just going to keep chaining as long as we hold down the attack button. So what we might want to do is make it so that after an attack enters, we immediately consume the attack value. So to make it so that you have to actually keep pressing the left mouse button to trigger the attacks to keep going, which is probably preferable, we might have to do something like if input.isAction just pressed player actions dot attack. Actually, let's say var attack equals this. We could call this is attack. And then we'll just set it on the blackboard. So, oh, no. We'll set it locally. It's bound, right? So attack equals. Yeah. Okay. I think this is what we want. Attack equals import is action just pressed. And then we delete everything else. So this means that when we have input, only if the attack button was just pressed are we going to have attack true. Otherwise, it's going to be set to false. So let's see if that works. I'm going to left click once, and you see that it doesn't change the attacks. But if we do left click, left click, left click, yeah, okay, that's not exactly what we want either, because there's like you can see that sometimes it switches to the event, but this actually requires it to be in a single frame. Let's say if input is action just pressed attack, then we're going to say blackboard. No, we're going to say attack equals true, right? But then on ground attack, when we enter, or when we change the animation, we want to set the value on the blackboard to be false. So we'll say blackboard.setVar bb names attack to false. And then down here as well, when we play an attack, we're going to set it to false. And here as well. So this is trying to turn it basically into a trigger where we tell it that it was pressed, but as soon as it's consumed, we set it back to false until we press the button again. So now if we go in here, I can left click, we get one animation. If I click twice, left click, then we get two. If I do 3 at the right times in sequence, then we get all 3 to play. And we can return to the base ground attack as well. So 1, 2, 3, yeah, 1, 2, 3. But we can stop at any time. So if we left click twice, we only get 2 attacks. Okay, and yeah, that's basically at least playing the animations for the ground state and returning back to the ground state when we're done. So I think that's going to wrap up this video. We still have to do air attack animations, and then I think we're going to add in the enemy movement and AI with behavior trees. I know it's taken a bit longer to get to that than we probably would have liked, but we're getting there, and we'll have the attacks ready so that we'll be able to basically hit the crab and deal some damage, put him in a hit state, etc. Once we get to that point. So thanks for watching to the end. Once again, the course project files are in the description, Ko-Fi and Patreon, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video we're going to take our character, which already has ground attack, ground state, and air state, where we can move around ground and air with animations, and we're going to add air attacks to it. So it's going to look very similar to our ground attack, where we can chain together 3 different attacks for the ground, but 2 for the air. And we'll basically be setting up a duplicate scenario, but only accessible from the air. So if we look at animated sprite 2D, we can see we have air attack 1 with 3 frames and air attack 2 that also has 3 frames. So we need to take those animations over to animation player by clicking on animation player. I'll go to attack 1 and duplicate this, and we'll say air attack 1. Zoom in on the timeline, enable timeline snapping to cursor, and let's click on this animation frame, change the animation to air attack. Now if we play it, we should have our air attack kind of play here. Okay, and now we need to adjust the position and scale of our collision shape to actually match this air attack. So I'm going to click on collision shape, and we'll scale it upwards. Be sure that you're not actually changing these handles on the collision shape, because if you do that, that's changing the shape itself, which was already set up for other attacks. So if you change the collision shape, because that's not keyframed, it's going to affect the other moves too. Just a gotcha of how I have it currently set up. But as long as we increase the scale here to where we need it to be and adjust the position, I think we can do W to adjust position still. And scale it to what we need it to be. Then we can keyframe the scale, keyframe the position, and okay, so now we want to go to frame 0 here, and we want to adjust the position and scale of our collision shape node so that it can be appropriate for our attack. So let's scale, hold on, we have to click on the sword collision shape and then scale this up. You can also scale X and Y independently if that helps. And then adjust the position. Okay, and we need to make sure we add the keyframe for these values. So you can click on the keyframes to double check that we have the right values there. And now if you kind of scroll on the timeline to frame 0, we should have the right position. So we need to do that again for over here. We can increase the scale and then keyframe position and scale. Okay, so here's frame 0, frame 1, and the second frame. Oh, really, it's the third frame. So for this one, actually, we're going to just disable the attack. So I'm going to right click on the disabled track, insert a key, and let's check disabled. So now it's going to be 0 where it's active, frame 1 is active, and then the third position here is inactive, so we don't need to set a attack position. So on the last frame, it won't be able to damage anything, basically. Now we need to do that once again for air attack 2. So I'm just going to duplicate air attack 1 to get air attack 2. Let's go to the animation, change that to air attack 2. And now just scroll and position the position of the collision shape. So now just position and scale the collision shape 2D as you need. And be sure to hit keyframe for scale and position. And we can kind of do the same thing there, position, position. And at the third one, what we can see that it's kind of already done here again. So it's up to you if you want the sword to still be able to damage anything at this frame or just disable it altogether. If you disable it, you don't need to worry about position and scale because it's already disabled. So it's going to look kind of like this for the hitbox, so to speak. Okay, and that's our animation setup. So now we need to duplicate, let's say, ground attack. And I'll call this air attack state. And let's jump into the code. So what we need is pretty similar to what we had before. What we could do is rename ground attack state. So let's look for ground attack state and call it something like attack chain state. Okay, hit enter there. If you want, we can make it a class name, attack chain state, because we're going to reuse it. So now on the air attack state, we're going to use air attack 1 as the enter, air attack 2 as the second, and we're going to leave the third one blank. So we can change the code up here a little bit. On animation finished, we were going to attack 2 and attack 3. So what we'll say is that if an attack is blank, then we will not go to it. We'll just dispatch finished automatically. So if attack 2 dot is empty, we will dispatch finished and return. We can copy that same bit down here, except with, let's see, attack 3. Yeah. All right, that should be good. So we just want to send the finished event if there is no attack to chain into. That should be good enough for right now. I think the last thing is that we need to know where we're returning to. So that's going to be set up on the state machine script. So going back into here, we want to be able to say that we go from the air attack state. So we haven't defined that in the inspector yet, to air when the finished signal is emitted. And then likewise, we want to be able to go from air to air attack when attack is added in. So add transition states air to states air attack, and that's going to be the attack event. So depending on if we're on the ground or air, that determines which kind of attack we're going to use. And now we need to open up this states dictionary. Just add in our new state node, which is air attack. And the value of the dictionary key value pair is the air attack state. And then be sure to hit add key value pair so it's actually in there. Okay, now to get the attack event to send out, I'm going to check the ground state because I think I had the code right in here. So if the attack var is set on update for ground state, we would dispatching an attack. So I think I'm going to just copy that over to air state and have the same thing. So on update here, we'll just copy paste that in. if blackboard get var attack var is set, and this was coming from the player import. So the player import will send when attack is used or attack button is pressed, and then we use that to create an event on the state machine, which will get us transitioned into our air attack. So let's hit play and see if that works at all. I'll jump and then we left click, and then we can have our air attack state just like that, which returns us to air state. So if we do one attack, we go back immediately. If we do two attacks, then, well, yeah, same thing, but we get both attacks off and then we go back to the air state. So that already is pretty much working exactly as we want. I might still want to double check a couple things, make sure that our air attack and air attack 2 have the right duration, non-looping, and that should pretty much be fine. Okay, so let's add in one more thing. So in air attack state as it is right now, our character completely freezes up. We turn off move and slide. Well, rather it's not running move and slide. So for some games, that might actually be what you want, right? You want to just stop the character's movement while it attacks. But let's say that you want it to be able to keep moving while it attacks, or at least have the option to do so. So what we can do is we can take ground state and air state and kind of turn those into more of a base state where we still have a ground, but this would be more like the ground move state. And then ground attack can inherit from the ground. So the ground attack can still use the ground movement because they both inherit from the same base state. And then air attack will be the same. We can enable or disable air movement for our air attack state based on whether we want that or not. So that will just be mostly reorganizing some code around. So to make it more clear though, I'll rename the ground state to be ground move state and air state to be air move state. Okay, and then I want to create a base state that extends character state for those. So let's go into player. I'll right click, create a new script. Let's call it, oh, well, hold on. First, I want to rename the other one. So this is ground move state, and air state should be, if I can find it, air move state. So now we'll create the ground state and the air state that is the base for those classes. So let's start with air state, since we're working on the air for this video primarily. And this will inherit from character state. Okay. And then air move state is going to inherit from air state. So now at this point, basically, air state is a base class for anything that happens in the air. So if we want to be able to add air movement in, we just inherit from air state. And then the same thing is going to apply for ground state, which ground move state inherits from. Okay, so right now it says that we can't find the base class name, so I'm going to copy that over to air state and give it a class name. Okay, that should help for inheritance. Okay, and now we're in there. So it says that these animations already exist in air state. When I created the script, I actually didn't mean for all this other stuff to come in here. So because that's an air move state, let me double check. Okay, it's should be all the same. And I want to cut all of this out of there. I want to cut this out too. Okay. So now air move state should be able to operate. What I want to take is this air move, and I'm going to put that in air state. So I'm going to cut this and paste it into air state. So now every air state has the air move function, which we can optionally use. And I can add in a variable to determine whether any given air state will actually run this or not by saying at export var, let's say can move, which is a Boolean. And we will default this to true, I suppose. Okay, and then on function update, we will just run if can move, then we're going to run air move. So this is not a function, it's just a property set up here. Okay, so now any air state will move by default if can move is checked. Let's go to air move state and see here. So since air move is being called in the parent state, we can just make this a super here. So we do the air move if it's there. Okay, we need to pass in the delta. So the super function still needs the same parameter. So we just pass that up. This runs the air move. runs air move. Then we get the animation and so on and so forth. Okay, and now if we click on air move state, you'll see that can move is checked. So if I hit play, we should still be able to move in the air. But if I uncheck, let's uncheck can move, and I hit play, then now our character can't move at all in the air. Which would be how the air attack was working before. So that may be what we want. I'm going to click on Limbo HSM. Let's just make sure. Okay, yeah, when we change the name of the nodes, it still has the reference. That's good. So now we're going to make air attack state inherit from, yeah, we'll make it inherit from air state. Okay, hit enter. If we have can move checked, then it'll be able to move. If we have can move checked on air move state, then it should be able to move. So now if we hit play and we attack, you'll see that it is actually attacking, but the gravity is not being applied. So maybe gravity is also something we want to move into here. So if we're going to do an air move, we probably want to also apply the gravity as we would expect. So if we hit play and now we jump and then attack, our character is still applying the gravity. We can kind of see though, if we say in the air attack state, while we're on the ground, that it keeps attacking, which is probably not what we want. So in the air move state, we have that check for if it's on the ground, then we're going to return to the ground. I'm actually going to put that in air state as well. So copying, pasting it in here, and this will dispatch on ground. So I want to add another connection from air attack to ground state. When we land on the ground during an attack, basically we automatically switch to ground. So our attack ends. So let's add that in. Add transition states air attack to states ground when on ground event occurs. So if we hit play and we jump and we keep attacking, well, you can see we switch to the ground, which is probably more like what we expect. So just kind of adding those extra transitions where it makes sense. Okay, and if we want the air attack to still not allow movement, then we turn that off, and then it'll be more like just like before. Okay, so one more thing. When we are attacking but not able to move, the velocity doesn't change, so we're unable to flip between a right attack and a left attack. So what you might want to do on the facing node is actually pull from the blackboard's direction instead of the character velocity. So if you want to do it that way, let's just say that you do, then let's get the state machine. So the Limbo hierarchical state machine, and then we'll get the blackboard from that. And this should look kind of familiar because we've done it before. So blackboard is going to be equal to limbo hsm.blackboard. And then we will get the direction value on every frame. So our current input direction is equal to blackboard.getVar bb names dot direction var. Okay, and this is going to be a vector2. So just like with the actual velocity, we're just going to replace this with our new vector of input. Now, as long as you assign the HSM, we should be able to grab the blackboard. And now, when we're doing our attacks, we're using the input rather than the actual velocity. So that could be a little more flexible in how you do your air attacks if you happen to be turning movement off. I'm going to turn movement back on for that. So that's going to be a lot more like this. And now we just need to kind of do the same thing with the ground state as well. So the base ground state, we have to create that. So ground state is going to inherit from character state. We'll create that. And yeah, it seems like when the script's name still exists in memory, that it just remembers all the other information that was in it. We'll cut that out in a second here. So not ground attack, but ground state. We'll get rid of all of this, and then we'll figure out what needs to go in. So we'll keep move and jump down here, but let's get rid of all of this, as well as these. Okay, now we'll go to character animation player. Well, I guess if we need that, then we're going to need the jump animation name after all. Okay, so we can keep jump animation there. so that we can still do the jump from any ground state. Okay, let's check out the ground move state now. So we don't need this because that's in the base class. But we do need to extend from ground state. Okay, and then we don't need jump animation because that is set there. You might want to make sure that the name of the jump animation is still correct here. So just check all your variable names. So just like with the air state, we can get this bit and move it to the base ground state. So we'll have function update in here as well. We'll have that, and we'll say if can move, then we're going to run these lines. I guess if we want to store the current velocity, well, don't really need to do that because when you move, it's on the character body anyway. So we can just adjust for that. So if can move, we have to export that variable. Can move is Boolean. We'll just set it to true. Then we're going to apply the gravity. So that's going to be, we can rename this to P delta if we want, or just delta delta. Okay, so there's our parent update. So let's go to the ground move state. And we're going to call super with P delta for our base movement. And then this can just grab the character dot velocity. Okay. Effectively ends up being about the same. I think we want to grab this out too and move it to the base ground state. So we'll say something like this. If the character's on the floor, we're going to allow it to jump. Let's add another variable, can jump, which will be a Boolean set to true. So if can jump, we'll say if can jump and these other requirements. Three if requirements in one line is kind of a lot. 3 if requirements is three conditions in one line is kind of a lot, but functional for now. We're mostly just kind of prototyping. So if it is not on the floor, then we want to dispatch that it's in the air. I think we still do want to do that. So we are probably going to want that on first frame back up here as well. So let's get on first frame. I'll put that in ground state. And after update is done, I'll cut that to the ground state as well. Okay, so now all of the ground states are going to have that so they don't accidentally just switch to in air before that first frame is up. But we are going to want a connection between, let's say, the ground attack and air state. If for some reason we happen to fall off a cliff while we're doing an attack, then we might actually need to just end the animation. Or maybe we don't. That's kind of up to you. In some games, I think when you do a ground attack, but you end up in the air, it would still finish the animation. So that's up to you. If you do want to add that in, then just add a transition from attack to air based on that condition of in air, I think it was. In air. So yeah, you could just make the ground attack to air as well. Right, so let's hit play and see if everything still works the same. It's looking good. We have ground attack. We can still move and attack at the same time. Optionally, we could go a little further here and make it so that when you attack on the ground, your movement is slowed or something like that, but it's just another layer of complexity. I think you kind of get the idea. We have like the slower movement in the air, so you should kind of already know how to do that. But that might involve getting separate variables for the speed, so you might have to like export the variable name and then get that from the stats block, so on and so forth. You know what though? Let's just show that. It shouldn't take too long. Okay, so we need to look up stats in our file system. We'll go to character stats. We could say at export var attacking run speed and make this a flow of 150.0. So now to differentiate between these for the ground move and ground attack, I'm going to need to open up the base class. Let's add an export var for movement speed stat name. Or movement speed stat var. Movement speed var. Okay, and this would default to run speed here. So when we move, we're going to get this value from the character stats. So var move speed is going to be a float. It's going to be equal to character.stats.get. We need to give it the property name here, which is this movement speed var. Paste that in there. And then whenever we use character stats run speed, we replace that with move speed. So that should just be 2 places here. And that's pretty much it. So first off here, we're going to use run speed, but on ground attack, we're going to say, hold on a minute. I see it. Hold on. Ground attack is actually using air state. Okay. So that should be using ground state now, right? And then that's going to have the variable here. So we're going to say attacking move speed, I think is what I called it, right? If we click up here, we can see it on the stats, attacking run speed. So on the ground attack, attacking run speed. And those should be different values. So one's 300, one's 150. Let's hit play. So here we have our ground attack where we're slowed down, and we move at full speed when we are in the ground move state. So that is one way how you can do it. If we like to be consistent with these other string names, we can also make that a string name instead of just a string. So I'll type it as a string name, but in pretty much all cases, a string name and a string will work the same when you're looking things up using property getters and such like that. Okay, so I think we've pretty much set up our character controller, at least for its attacking states. Oh, it looks like the air attack is not going back to the ground again. Let me make sure about that. Air attack. Okay, so I made air attack. Oh, hold on a minute. Yeah, right. I need to actually separate them into separate scripts. Okay, duh. So let's see here. So we had attack chain state. This would just be ground attack state now. Yeah, so I guess the inheritance is getting a little messy. Okay, this definitely isn't the best way to do it, but it is the quickest. So I'll say air attack state, and then we're going to go into air attack state. I'm going to paste everything in, and then we'll say class name air state. Extends air state. Could not find base class air state. That's odd. Air state's right there. Okay, looks good now. So if we click on air state, we need to make sure that we assign air attack state. Okay, that's a little odd. Let's unset that, and I'll drop in air attack state right there. Okay, so we'll need to set air attack state into here. Okay, and that should look more familiar now. So air attack 1 goes in here, air attack 2 goes in here, and the ground attack state is still using ground attack state, which is what we want. And that has all of the ground state variables. So I think if we hit play now, okay, our ground attack's working, our air attack's working, and our air attack can go back to the ground. Okay. Yeah, now everything's working pretty okay there. Yeah, okay, so that's a pretty clean state transition between these different states. After we add in like enemies and such, the character probably needs a hit state and maybe a death state, and that's about it. The last extra thing, make sure in the ground attack, since that has jump here, I am going to set the jump animation name to jump S, but I'm also going to turn off can jump. And also, if we're going to leave jump enabled, then you're going to want to be able to transition out of ground attack into air. So let's go into Limbo HSM and add a transition for states when we're on ground to states air. And that's going to be the jump event. And that's actually ground attack or just attack. That's what we're calling it as the string. So yeah, let me see on the base ground state, we get the in air and jump. So it dispatches jump. Okay, so that should work. If we're attacking on the ground and we hit jump, well, we're going to get into air move. Unless we happen to be spamming the left mouse button, then it's going to look like we immediately go into air attack. But yeah, when we're in the air, we should stop with our ground attack. I think that makes sense. Or at least when we jump, we should stop with the ground attack. Okay, so just wanted to add that in, one extra transition, and that's pretty much it for the video. As well as the sword needs the ability to actually deal damage to the enemy. but that is going to require adding in health and a couple other things. We will get to that in the next videos, kind of after we add in the AI for the enemy. That was kind of more of one of the main focuses of the course. And then we will finish up with adding in the actual damaging and hitting and maybe seeing some text numbers and a health bar, that kind of thing. We'll get to that. So that's going to be it for this video, kind of wrapping up the base of our player character's state machine with the LimboAI system. So until my next video, I've been Chris, thanks for watching, and I'll see you in my future video content. Hello everybody, Chris here, and in this video we've already pretty much got the character controls for the player's state machine already working and going with input and the states. So at this point, I think we're ready to move on to the enemy's behavior tree setup using LimboAI. So one quick fix I want to make before we get into that, if you look at the character's ground attacks, you'll see that it reverted its movement back to the regular run speed variable. So if I click on ground attack, in the last video we set up a movement speed variable, so we can set this to a different one on the character stats. If we click on the root and look at the stats, we wanted attacking run speed to be the variable here, not run speed. So I just need to get this property. I can right click and copy the property path, I think, and go over to ground attack and just paste it in. Yep, there we go. So if we hit play and we start attacking, you'll see that it's using the slower attacking run speed for movement during the ground attack state now. It was working like that before, but I guess it must have got reset at some point somehow. So anyway, that's fixed. So let's move on to the LimboAI for the enemy. So in the characters enemies folder, I'm going to open up the Krabby scene. Right now, there's not much in here. We've got an animated sprite 2D. We have all the animations imported by using Aseprite Wizard, which basically just converts the Aseprite file into an animated sprite 2D. And then in the animation player, we can see that I actually have all of the animation names imported here. They're all currently blank. So these were supposed to be not here. I think it was from some test script I was working on before starting the series. So I'm actually just going to go up here to edit the animations and just delete that whole library. We'll recreate it, if not in this video, in the next couple for the animations we need. So just want to remove that so it's not confusing for anybody. Okay, and now we want to add in the behavior tree finally for our character. So I'm going to right click on Krabby. We're going to add a child node, and we want to search BT for behavior tree. So we want a behavior tree player, which is essentially the root of our behavior tree. We'll create that. Now you'll notice that there was no behavior tree node that gets associated with here. Instead, behavior trees using LimboAI use resources instead of nodes in order to create the tree. So other behavior tree plugins like Behave would use a node-based approach. Both can work perfectly well. I just wanted to point out that distinguishing factor. So to start creating our behavior tree, we can see in the inspector of the BT player, of course, it's an empty behavior tree right now. So if we click on this and hit new behavior tree, and we click on behavior tree, it's going to jump over to the LimboAI behavior tree editor. You'll see a whole bunch of tasks over here on the right, and these help us to set up essentially the AI for our character. We can also see that at the bottom, we have a little warning, task folder not found, resources AI/tasks. So that would be the default path for where we have our Blackboard tasks stored if we want to create custom ones that we use in our behavior tree, which will be set up here. So if we click edit path, you'll see that it mentions that for the GD extension version, at least, we have to navigate to project settings. So we could do that real quick. And then I think if we scroll down here to the bottom, you can find LimboAI behavior tree and set the directory here. Or if you prefer, you can just hit create and that'll automatically create the AI tasks folder. So if you need to create a behavior tree task, a script that extends it and has its own custom code, which we'll probably do during the remainder of the series, then those just go in here so they can be found and recognized in this window over here. Okay, so for now, what I want to do is take this new behavior tree we just created, and I'm going to right click and save it into our characters folder, enemies, Krabby, and we could just rename this something like Krabby AI or Krabby behavior tree, whatever makes sense to you, just so that as we're editing this, if for some reason the reference ever gets lost on the inspector of the behavior tree, that we don't lose our entire behavior tree setup. That would be pretty bad. So I do recommend saving these directly to the file system so it is not tied to anything specifically, but it just is a file on your project, and as long as you don't delete that file, you can always recover it. All right, so one of the first things we're going to need our character to be able to do on the level is to navigate to a new location. So that, for this character at least, will pretty much just mean going left and right, for now at least. So we're going to need to tell a navigation agent 2D to try to go left and right until it would, let's say, hit a cliff or something of that nature, and then stop, maybe reverse or jump over the cliff. It depends on how we want to set up the character. Before we get into that, I do want to set up a couple animations and just make sure it defaults to the idle. So let's go to the animation player, and we'll hit new. I'll just say idle animation. We're going to add a property track for the animated sprite 2D, the animation, where on the first frame, we click here and we'll set the animation to be idle. Okay, so now if we play that animation, okay, it should go back to our idle first frame at least. I also want to take the snapping and change that to 0.1 seconds. It gives us 10 frames per second for animation. Enable timeline cursor snapping. And now we can add the property track for the frame. So this is very similar to how we were working with the clown nose player, because this is also animated sprite 2D based. So insert the key. Let's make sure this snaps to the 0, 0. And that's going to be our first frame. Next frame at 0.1 seconds. Insert key, change it to 1, and just do that as long as we have frames of animation. To see how many frames of animation we need to cover, click on animated sprite, go to the idle, and you can see there is 9 here. Starts at 0, so 0 is the first frame, plus 8 gives us 9. Animation player, we just need to keep doing that. So insert key, make this a 3. Next one becomes a 4. Yeah, this should be a 2 right here. And then 3. Okay, if it's not actually setting the value there, it might be because the animation is playing. So go to the animated sprite 2D and hit stop. Then we'll go here and change this to 2, hit enter. Okay, seemed like I accidentally renamed the idle animation to just S, so make sure you don't mess with the animation names there. Let's go back here and hit play. Okay, now we should be able to click on here. We get frame 2. Here we set to 3. Here we set to 4, and keep doing that all the way up to 8. So let's do 5 here, and then 6. Insert key, 7. Insert key, 8. And then stop the animation at 0.9 by changing the duration over here to 0.9 and enable looping, hit play. And there's our idle animation playing on the animation player. So let's duplicate this for the move. I'll duplicate and we'll have move animation. We click on the animation track and change this to run. So if it makes more sense, we could actually rename this animation to run as well. And we can see that this only goes up to frame 5. So I'll delete these extra frames. And I'll cap the duration at 0.6, hit play, and there's our run animation. I mentioned we need a navigation agent in order to navigate the game world here. So let's right click on Krabby and add in a navigation agent 2D. So this is going to use pathfinding in order to find the final destination for where our character needs to go. And more or less what we just need to set on the navigation agent is the destination we're trying to get to. And then it uses, I think, an A-star algorithm internally in order to find its path to the destination. So we will need to set up the game level to be able to have navigation enabled, giving it a area where it can navigate in and handle the collisions here on the navigation map as well. But it's actually not too bad to get that set up with the default nodes in Godot. So on the BT player, the behavior tree, we're going to need to know about the navigation agent so that our behavior tree logic can tell the navigation agent where it's trying to go to based on whatever inputs we give it. So you can either add the navigation agent onto the blackboard, which would look something like this, clicking on the BT player, expand the blackboard plan, and edit it. And then add a variable, let's just say navigation, and then we could say node path here. With node path prefetching enabled, it'll get the actual node once the player initializes. And then you can just assign that to the navigation agent. And then now you have access to the navigation within the blackboard here. If you think that every enemy is going to be using this kind of setup though, it may make some sense also to kind of go the route we were going with the player, where we just have a character, or in this case, it'll be an enemy that extends character, has some properties that are preset. So once we have access to the agent and then we cast it as a enemy, then we already know we have access to a navigation agent because every enemy has a navigation agent. I think that might be the way I prefer to go this time. So I'm going to remove it from the blackboard, and then we don't need to worry about it being on the blackboard at all because we'll just have it on our enemy script. So let's add in a new enemy script. I'll attach a new script to the Krabby, and this is going to extend character, and this will be enemy.gd, and we'll save it in the enemies folder instead of the Krabby specifically. So create the enemy script, and I will give it the class name enemy. Oh, you know what? Even better, we could just call it NPC. So let's find enemy and rename it NPC. I'm going to take NPC script and I'm going to move it to characters. That way, if we had any neutral characters in the game, they could also have the same navigation system. So just making it like as generic and wide branching out as possible, I think makes some sense here. So this is going to be for any character that's not controlled by the player. We want to have a export var for navigation, which is a navigation agent 2D. And now on our Krabby, we can just assign the navigation agent 2D. And now if we want to get access to this navigation, we just need to cast the agent as an NPC. So let's see. In AI tasks, we could create our first task for navigation. So let's go to AI tasks. We create a new script. It's going to be, let's say, navigate to point. You could call it underscore task if you want, but I think it's already implied because it's in the tasks folder. And this is going to extend BT action, I think was the one we wanted. There's also BT task, which is more of the parent class, but because we're taking an action here, we want the character to actually navigate and follow through moving to the point, that this is something that's going to take over multiple frames. So BT action, I think, is the base class we want. So we can open up this script for editing. If we look at LimboAI, we should already have the task under miscellaneous here. So it's put under miscellaneous because we don't have another parent folder. So we might want to do like right click here and say folder navigation or something like that, and then just move navigation to point into that. And I think the next time we look at this LimboAI window, it'll automatically update. So now it's under the navigation category. That might make sense if you're going to have multiple navigation tasks. So you can just organize your folders like that so that they show up here how you want them to. So if I right click on the BT action symbol, lookup symbol, and go to BT task, which is its parent, then you'll see that there's a bunch of methods that we can override. And it's going to look a lot like a state machine node here, right? Because we have enter exit tick, which runs when the behavior tree is actually operating on that task. And then setup, we're going to want to make sure we grab the navigation node from the agent. So let's go navigation to point. Let's implement our setup function. We could say something like var npc is of type npc. And when we enter the setup for this function, we're going to take the agent and cast it as a NPC. So NPC equals agent as NPC. And then we already have the npc.navigation here because NPCs all have a navigation property. So when we enter this node, we want to pick a new point to navigate to and actually get there. So function, and this is underscore enter. And we could say something like pick destination. So what are we going to do in pick destination? We're going to pick a new point that the NPC can navigate to. So for our navigation, we might want to just pick a random point, either to the left or right with a max distance. And when it gets to that point, it's going to stop and move on to the next AI task. So let's say in the inspector, we can just do like a max distance, which is going to be a float. And we could default it to like 200 pixels. Whatever the value you think is good, you can always change it because it's an export. And this will be the max distance to the left or right from where it currently stands. So to pick a new destination, we need to know the current position. So let's get the current position. And that's going to be equal to npc.get global position. Okay, I think that will work here because, yeah, right, because every NPC is a character body 2D, which is a node 2D, which has get global position as a method. So we have the global position, and then we need to pick a random value between -200 and +200, plus or minus the max distance, and try to navigate to that from the current position. So let's create a random number generator, I think. So RNG, random number generator, we can say RNG equals random number generator dot new. So we get that, and then we need to get the offset. So if our offset is going to be equal to RNG dot random float range, and that's going to be negative max distance to positive max distance. Okay, and then we get that random value, the offset, we just add that to the current position dot x. So the new destination is going to be a vector2, which is going to have the current position dot x plus the offset, and then the current position dot y. So let's return the new destination. So this function will return a vector2. And once we have that destination, we're going to set the destination on the navigation. So npc.navigation dot, I think it's called dot, let me scroll down here a bit. What was the target position? Hold on, is it target? Yeah, okay, target position. So the property you want to set on the navigation is target position, and we set that equal to whatever we get from pick destination. And then from there, we just need to move the character towards the destination, or towards the next path point, rather. You'll see more about that visually when we have this running and we enable visible navigation. But yeah, it wants to move to the next point in the path, which eventually gets us to the destination. And we want to keep doing that until the navigation says that we are at the destination. So we're going to be running all of that on tick. So the tick function is kind of like update on a state machine state, or it's like the process function on any node. This only runs when the behavior tree is currently acting on this script. So the behavior tree will have a big selection hierarchy to determine what step it's trying to actually do for the AI of our character. So like before we get to, let's say, the player position, we have to navigate there. And then after it detects that we're at the player, we can start attacking the player, that kind of thing. So it's just a hierarchy of commands that one has to occur before we can continue with the chain. So let's see, for function tick, you want to return a status. So the status is either running, success, or failure. Generally, if the status is running, it's going to keep looping through this tick until it gets to a success or failure. If it's success or fail, generally, it either moves on to the next action on your behavior tree, or it's going to return back out so that it can select from a different part of your AI. And that depends on, if we look at the LimboAI here, that depends a lot on how you set up your composites here for what happens on success or failure, or if like all of the nodes have succeeded or failed, then you move on to something else. And it can get a little confusing, and there's definitely a learning curve to it. Okay, so our navigation to point. We want to check first if the npc.navigation is navigation finished, then we'll return success. So the status code is just either success, failure, or running. We could also say here if npc.navigation. There's one for like if it can still get to the point. So let's see, is target reachable? Yeah, okay, there we go. So if the target's not reachable, and I'm going to put a not keyword here, then we're going to return failure because there's no way for our character to actually get to the point it's trying to navigate to. So we're just going to stop trying to attempt that. Otherwise, we're still running here. So at the end here, we'll just return running. And then somewhere in here, we want to have our movement command. So let's just say something like move, and then we'll have to create a move function. Okay, if we click on Krabby and we look at its root, you'll see that there are also stats of the character. I'm not sure, did we create stats yet? No, we didn't. So we could create like a new NPC stats or character stats. For now, I think we can just make it character stats. So that gives us all of these move speed values. So we'll use that in our move command here. The character, I also want to assign the animation player and the sprite node. so that we have access to those later. We may need it in some of these behavior tree scripts. So when we move our character, first we want to know the direction to the next point. So let's say var move direction is equal to npc.navigation.getNextPathPosition. And we could say the npc.globalPosition.direction to the npc.navigation.getNextPathPosition. And if that's too much for one line, then we'll just move this out to its own line. Then we can say up here something like var next path equals, control V, paste it in. So we're going to get the npc global position direction to next path. Okay, so we know the move direction. Now we need to create the move vector. So let's say new velocity is equal to the move direction times the npc.stats.run speed. Okay, and we don't need to worry about delta because we're using move and slide, so that's already automatically calculated in for us. So we want to do the npc.move and slide, but we haven't set the velocity yet, so we have to do npc.velocity equals the new velocity. That's going to give us our move. And we don't really need to return anything for right now, so I'll just not have a return. We'll just execute that. So we have move here. Our character's going to try to move. Okay, and that at least is the base of our script. So I'm going to add into LimboAI now. So in here, let's start with a sequence node. So a sequence node is going to do all of these tasks in order until they are all finished or one of them fails out. So the task we want to try to do is navigation to point. And we already have our max distance here. You can customize the names to be more descriptive. So by default, it's just going to show the name of the script, basically. But it could show something like navigate to a point within. Well, it would be easier actually to just show the code. So let's actually create a override for that. So let's do function underscore generate name, and we're going to return the name, which is going to be navigates to a new point, max distance, let's say %s, to the left or right of where the character is. Okay, and then to replace this %s with a string, I'm going to do % at the end and say max distance. Okay, now if we look at the LimboAI and maybe I have to go back into it. Let me actually try reloading the editor real quick. It should show. Okay, we look at LimboAI, click on our BT player, click on the Krabby AI, and it's not. Is there an error? Oh, yeah, right. Okay, so scripts can't actually work in the editor until you add the at tool at the top. So we just have to go up here and say at tool. So this means that parts of our code can actually run in the editor if we decide to call on the different functions. So the generate name will call automatically inside of the behavior tree. So if I click back on LimboAI now, and I click around a couple times, this will refresh. So now it's going to show something much more descriptive. Navigates to a new point of max distance, 200.0, that's the max distance, to the left or right of where the character is. So I think using generate name in that way just makes it a lot more descriptive what your character is actually trying to do. We could rename this sequence to be our, I don't know, find targets sequence or something like that. Okay, now as things are right now, if we run, I would expect to get a bunch of failures because we don't have a navigation map inside of our game. So if I hit play, you can see that it's immediately going to return false, even if we have picked a destination out. And let's see if there is actually a destination. If I click on NPC navigation, does it say anything about our destination? I think in the inspector, it doesn't actually show up here because it's not an export variable. But what you could do is you could say print npc.navigation.target position here, hit play, and we should get something in the output. Yeah, you can see that it keeps re-entering this this script, right? Because it's the only script in our sequence. This one fails, so it tries to go back up here and start over, which means that it's just going to keep going in here and setting a new point. Destination fails, goes back in here, so on and so forth. So not entirely helpful for us, but at least we know that it's running as we expect it to at this point. So you want navigation inside of your game. That means we need to have a navigation map layer. let's see, what was it called again? If we add a new child, navigation region. I think that's what we want, right? And then if I recall, you create a navigation polygon here. So let's create that. And our navigation polygon, we just put the points for our level. Basically, just to make it simple, we can just put our bounds for the navigation around the outline of our level and just kind of try to snap them, make them straight and even. Of course, you can always adjust the points later. Okay, so I'm not sure that one connected, did it? Can I see the points here? Okay, and to make sure that it actually connected, if you drag this, it should move both handles to the left and the right. Okay, yeah, so there we have our navigation area. So right now, wherever it's showing the slight blue, that means that it can navigate those regions. If we do bake navigation polygon, you'll see that you can see that the walls here are still considered navigatable, which is not good because that's going to result in our character running into the wall. Okay, so to include the tile map layer in our navigation region, there's a few different ways you could set it up. One would just be to take the tile map layer under navigation region and then go to navigation region and hit bake. So now basically anything that's a child of this can be included for its collision shapes and removing it from the navigation map. Or if you don't like having to set up the hierarchy that way, you can click on navigation region, go to navigation polygon, down to geometry, source geometry node, and you can do group with children. So you could either use this group name or you could just say maybe navigation and then click on tile map layer, go to node groups, add the group navigation, hit enter, or just add that, add the group navigation. This can be a global group, sure. Hit OK. And now, because it has the group name, this and any child nodes of this should be included. If I hit bake, then it will work as well. So that's a couple ways you can do it anyway. Okay, so we can see that it does put quite a bit of distance between the actual collision shape and the navigatable region here. So if we hit play now, it'll sort of work in some ways. Obviously, it's getting kind of stuck there. So some of our setting we might need to tweak. So let's try changing the settings here to see if that affects anything. Right, okay, so we can see it's also trying to navigate over the wall, which, you know, on one hand sounds handy, but on the other does not make sense for a character that is not actually flying around. So we can definitely fix that. Let's go into the behavior tree for the AI and jump in here. So in our move, we're definitely getting the next path position. But when we get the direction to the move direction, we only actually want it to be the .x that gets passed along here because this is movement for a ground character. So we're going to say here vector 2, and this is going to be the direction to .x, and the y is just 0. So a character cannot fly. It's just going to move along the ground. Okay, so if we hit play, we may see that our character gets stuck on walls like this if he ever comes all the way over here, because now we're only saying that the character can move to the right, even if technically the navigation agent would be able to navigate over to this using the A-star algorithm. So if we still want to use it that way, then we would want to jump at this point to have the character kind of jump over the wall, or try jumping at least. So we can just combine that, I think, into the navigation script. The ability for him to jump or not jump. Maybe the move directions actually, maybe the move and jump functions actually get pulled out of the logic here and just put on the main character as a function it can do, and then the logic just calls that function at some point. For right now, though, we'll just keep it inside of the AI script itself. So first, we're going to take this out and paste it in here. So we're going to get the next path position. So if the next path position has, let's say, the need to go up on the screen, then we're going to tell the character to jump instead of not jumping. So let's say if the next path.y, and let's pass the move direction into this over here. So we'll say the move direction, or desired direction, is going to be equal to this bit over here. Okay, so we pass in the desired direction into the move. So p desired direction at vector 2. And then our move direction is going to be this dot x and 0. So if we actually call the move, we're just moving horizontally. Horizontal walk slash move action. All right. So that should work just like it did before. But what we're going to try to set this up is if the desired direction requires us to go up, then we're going to jump instead. Okay, so before we hit play and test again, let's click on Navigation Agent and enable debugging. So now when we hit play, we'll be able to see where it's actually trying to go to. So first off, it hasn't recalculated the path. So that is something it should be doing. We can also see, of course, that trying to get to this next point requires us to jump up. So we'll try to do that soon. But let's also recalculate the path. So in the AI script, whenever we get to here, before we do the next path position, let's say npc.navigation. Maybe it doesn't actually need to refresh the destination because the navigation map is still the same, so there's no need for that. Okay, but either way, yeah, we need to check the desired direction, and if the desired direction requires us to go up, then, so we'll say if desired direction dot y is less than 0, then we're going to try to jump. So we'll say jump, and then we'll try to move in the desired direction. We might say like else move, but let's see how that goes for right now. So making the character jump, let's say a variable jump, and we'll say that the npc.velocity.y is going to minus equals the npc.stats.jump velocity. And I think I am actually going to want to move these out from this navigation script to the NPC script itself. So let's jump into the NPC script and just paste these in here. So now all NPCs are going to have these functions they can call. And because it's in the NPC script, we don't need to have the NPC dot. We can just remove those because it's already implied that we're in the NPC calling these functions. So just remove the NPC. Let's go to navigation to point, and now we can do npc.jump or npc.move whenever we need. Okay, no colon there at the end. Okay, let's set a breakpoint here and see if that actually triggers. Well, it does immediately, right? So we also want to make sure that the character's on the ground before we do that. So let's say and npc.is on floor. Okay, as a prerequisite to jumping. So let's close that, hit play. And, well, do we get any kind of jump? It's still trying to jump. Maybe I had that wrong. Maybe it's supposed to be plus equals the stats.jump velocity. Let's try again. So we have jump occur, and it's not actually doing that, right? Okay, so like our move is setting the velocity, but really it should be only setting the x velocity, right? So yeah, we'll say move velocity is this. Okay, so here our move velocity has the direction times the stats.run speed. That's not exactly right though. I think we want to have another vector here. So it's going to be move direction dot x times stats.run speed and whatever the current velocity dot y is. And that's going to be our new velocity down there. So that way, if our character's falling or jumping, we don't completely override that velocity. We're only affecting the left-right movement. And that should allow our character to jump again. So let's see if he goes over here to the right. Still not jumping. And that's probably because I did this. So let's do minus equals. Okay, and he went somewhere, so the jump's probably working. Yeah, okay, well, it kind of worked. Okay, let's hit play without any breakpoints. It shouldn't be able to keep doing that. So the problem here is that we don't have any gravity applying to the character. So at some point we need to apply gravity just like with the main player. So let's say function apply gravity. Let me just kind of grab that from the player script or wherever we had it. Maybe it was in character state. Yeah, okay, let's right click here and get that symbol. I'm just going to copy this over to the Krabby script. So that is going to be the Krabby script here. We have apply gravity. And just kind of paste that in there. I'm going to make this non-private just in case we need to apply gravity manually from any other script for any reason. So if the character's not on floor, so if not on floor, then we add the gravity velocity times the delta. So it's not character dot velocity, it's just get gravity and then times p delta. So I guess we would say that whenever we move, we want to apply gravity, for now at least. So that's going to be times the delta, huh? Well, for right now, I guess, let's just put in the physics process and apply gravity here by the delta. So now that should just be regardless of what's going on with the character, we're going to apply gravity. Okay, and there you can see he's jumping around, but gravity's actually affecting him. So we kind of got a crazy character going on here. Now he's not really navigating to anything particular, it's just picking random destinations. And I think we want to make it so that the y value has to be like over a certain point, right? So it should be like more than the angle that the character can move at, which by default is like a 45-degree angle that the character can just walk up a slope. So let's jump into navigation and point, and instead of the y direction being anything less than 0, why don't we say that the y value being less than 0 has to be greater than the absolute value of the left-right movement. So if that was the case, then that would imply, I think, that the angle is above a 45-degree angle, and therefore it wouldn't be able to just go up the slope here. If blocked on wall, or maybe it should be more like if it's on the wall. Yeah, right. Okay. It's on wall and NPC dot is on wall. Okay. So if it's on the floor and the wall, then we'll try to jump. That might be interesting. Let's try that. Okay, there. Yeah, it just jumped over the wall once. That's a lot closer to what we want, right? And so that we can actually see it consistently, let's jump to the level, and I'm just going to put in a wall to the left here as well. So tile map layer, let's paint in a wall. So I think if I just like select these tiles over here, we can just paint it over here as well. And then we go to navigation region, bake, and there we have our wall on both sides. Okay, so yeah, the character is pretty much jumping over any obstacles like our character that it needs to in order to navigate to the point it's trying to get to. We can see here though, if the point is directly above the character, then it's not jumping. So let me see here. I guess what we'll say is if the point it's trying to get to is directly above the character, but we're not navigating over a wall like this, but like if the X movement needs to be 0, but we want to go straight up for Y, I'll just say that it fails the AI because we don't really want it to just be jumping in random places. So we'll say if, let's see, if the desired, okay, let's actually create a function for this because I think the logic might be a little complicated. If reached, okay, we'll say if reached horizontally, but vertical offset. Okay, that is a terrible function name, but I'll create that for now. We'll put it down here. So function, if it's reached horizontally but vertical offset, then we're going to return a bool. So we're going to say if the, do we pass in the direction? I guess we'll just pass in the direction here. Desired direction is a vector 2. So if the p desired direction dot x is, well, let's see, can we do float but approximately 0? No. We want if is 0 approx, right? And then we say b desired direction dot x. So if the desired x is almost 0, then we've basically reached the point horizontally. And then if let's see, we kind of want like the distance. So should we be getting the distance? Bar distance 2 equals npc global position dot distance to the next path. Then we can paste this in. P distance is float. If the p distance, you know what? We might not even need that, I think. So we'll just return true, else return false. Oh, I just returned false down here. We don't need to pass this into that, and we don't need this for now. We can calculate that any other time. Then we're going to return failure, because we've already reached the point we're trying to get to. So it could either be failure or success. It kind of depends on how you want to interpret that. But the point is that it's going to stop trying to do that move. It's going to move on with what it's trying to accomplish, so to speak. Okay, that's a little odd. What's going on there? Are we hitting that return failure? Okay, so I'm just kind of like hitting play now and watching it run a few times. Gonna hit F5 to refresh and just reset it. And I think for the most part, it's doing what we want it to, but obviously there's some weird quirks. It also moves kind of fast. So I might like slow that down. And we do want it to be playing an animation when it's actually moving. So let's add in the move animations. So the animation here for idle. Oh, you know what? Let's see, where should we actually have the animations being controlled? We could in the NPC have like an update move and idle animation function too. So let's see, update. Okay, play velocity animation, play movement animations. Right, okay. And you know what? Select movement animation. Animations might make more sense here. Pick some movement animation based on the current conditions of the character body 2D. So if the character's velocity is approximately 0, then we will take the animation player. I think we already have reference to that on the NPC script. And we're going to play the idle animation. So let's put that up here at export var idle anim string name equals idle. So we'll play the idle animation. Else we'll play animation player dot play, and this will be the move run animation. So put that up here at export var run animation string name equals run, and let's just put that on physics process. So like we might change this stuff around later on, but I think that'll work pretty good for right now at least. So in our NPC, it should have been there. Maybe I need to refresh here. Okay, it's definitely an export variable. So I might just need to reload the project. Okay, so we have those animations. So if we hit play, it should be able to select between those. Okay, so it's moving, so it's playing the run animation. That's kind of what we wanted to see. Okay, and to go along with that, we can also have the facing. So kind of like this in the clown nose, we want it to be grabbing the direction variable from the blackboard. We'll actually do that kind of the same way as the facing script. I'm going to add an extra export here for, let's say, behavior tree, limbo BT, limbo behavior tree, or BT, what was it, BT player? Yeah, okay. So BT player. Okay, now let's throw this over on the Krabby script, or rather a child of it, node 2D. So now back on the Krabby scene, let's add in a facing node. So I did make that a class name, so that's pretty straightforward. And then this time we're just going to use the BT player instead of the Limbo HSM. But inside of the script, we'll just say that, okay, we'll say if Limbo HSM does not equal null, then we'll get the blackboard from that. Else if BT player does not equal null, then we'll get the blackboard from the BT player dot blackboard. I don't know if these inherit from a, hold on, Limbo HSM inherits from Limbo state. Yeah, so they have different base classes, so we can't just use like a parent class here. But this works well enough. So one script just covers both bases, and we need to get the direction var from the BT player. So the direction var on the BT player is not set up. So let's add in the direction var, which is the direction the character is trying to move in, which will be a vector 2. And now, as you might imagine, we need somewhere to set that direction. So if we go to the logic script, the behavior tree node, we're going to get that next path position. So the desired direction is the direction we're trying to move to. Right. So how do we want to do this? I guess we'll just say after we get the desired direction, we do blackboard dot set var bb names dot direction to the desired direction. And now the facing script should be able to access that from the blackboard as well. Let's hit play and see if it flips. Okay, that did not work initially. So BT player, we have that default value, right? Okay, gotta make sure that the blackboard plans are kind of like the same. So gonna open up the enemy Krabby AI here. And it could just be that this blackboard doesn't have it. I see it there. So direction. And then on the BT player, it's like the same blackboard plan. It could be that the blackboard hasn't been set or something. Let me hit play here. We do get the BT player to grab the blackboard. Yeah, but that only seemed to happen at the first frame. Okay, now it's seeing that there's the direction var, but it's not setting the direction var, is it? Or is it? Hold on. I'll hit play. No, it should be facing to the right, but it's not. Let me try this instead. I'll make desired direction a local variable, and then we'll bind it. So desired direction is a vector2, and on setup, we'll take the blackboard, and we'll bind the var to the property. So bb names dot direction var, and it's going to be self, and then the property name is the desired direction. Okay, then we don't need to worry about setting it. So now this should be synchronized with the blackboard. Let's hit play and see if that works at all. Nope, does not seem to. So I'll test the direction to see if it's getting set by doing a print on the blackboard.get var bbnames.direction var. Okay, so if we hit play now, let's hit output. And it's set to all kinds of things, right? But it's not flip. Oh, wait, no. It is flipping the character, right? Okay, that's why print messages like that help. It's because we have nothing under the facing, so the facing isn't affecting anything. So if we just pull this up here, and we hit play, now the animated sprite is a child of the blackboard, so it's going to actually flip because the facing node is flipping. But it appears to be going backwards, right? So if I do the idle animation here, yeah, this character happens to be facing the reverse direction. So, I mean, there's a bunch of ways you could fix that by like changing the sprites to all face the same direction, or we can change the scale here and make it -1.0 on the animated sprite 2D node. And if I hit play, well, that's going to work for us because we're just reversing the direction. Okay, yeah, that's working pretty okay. So I do see a bunch of little error messages coming from the animation player. We might need to check the idle animations and just make sure that these are still consistent. And then here we have run animation. Okay, so that seems to be working all right. So let's see, it can't resolve the reset track and can't resolve run. Okay, that's interesting. Okay, so it seems like if you just reload the project, it'll automatically resolve like the new path to the animated sprite 2D and so on and so forth. So don't need to mess with that really anymore. So yeah, once again, if we hit play, we got a character basically able to jump over the walls. It's navigating pretty randomly, but overall it does a good job of detecting when it's at the wall and trying to jump over it. So that's going to resolve this first video, setting up the navigation agent, the navigation map, and adding in one navigation AI task for our character. Going forward, we probably want to detect the player. So adding in a sensor node where we can pick up the player, move to it, and attack it as its own part of the behavior tree. So that's going to be it for this video. We'll get to that stuff in the next few videos and kind of wrap up our enemy. So thanks for watching. I've been Chris, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video we're going to go from just having the find target sequence of just trying to have the character move to a target and jump over walls, including players, to basically if we happen to have a sensor that detects a player and that player is within range, then we're going to try attacking it. So let's start by adding extra leaves to our behavior tree. So first off, to have the base of the tree, you have to use a composite, I'm pretty sure. So I want this to be a dynamic selector. So I'm going to click dynamic selector, right click, make it the root, rename this to be Krabby AI. And what a dynamic selector does is it goes through each of the conditions and checks if they are able to run. So what a dynamic selector is going to do is go down the list and try to run each task. When those tasks, so what a dynamic selector is going to do is run each of its child tasks, these children leaves, and run each of them until one of them returns a success. And on every tick, it's going to basically cycle through all of them and start from the beginning again. If it was like a regular selector node, then it would keep going until the entire tree is finished and not return to the start. So when you have a dynamic composite, it always returns to the start as it tries to go down the list of tasks to do, and then returning back up on the next tick again. So basically, when you use the dynamic selector, you can be sure that anything under it or directly under it is going to run on every frame or every update for the behavior tree. So what we want to do is probably have like a sequence here that ranks above find target sequence. So that's going to be the attack target sequence. And first off, we need to check a variable on the blackboard. So we're going to check if the player is recognized as an attack target. So we'll do check var, and let's say variable name target, and then we'll click this button over here to add it to the blackboard plan. So add variable target, and this wants to be an object reference. And let's say attack target for the character. Okay. When it's on the blackboard, you'll get this verification check mark over here on the right. And we want to make sure that this is equal to not null. So when you create a new BB variant, the default is null. So we want it to be not equal to null. You'll see that the name of that task gets updated. So we can only attack if the target is not null. So then we want to give it like an attack cooldown, right? So that we can't just play the attack repeatedly over and over again for the enemy. We'll say cooldown of 1 second. Okay, so after having the cooldown of 1 second, we could add in the attack target task, right? Like just like we did navigation to point, but we can actually make it easier than that. If you recall the Krabby animation player, our attacks. Oh, I guess we didn't set that up, but for the player we did. So if we look at the player's animation player and ground attacks, then you'll see that these already kind of have the collision shape set up. So all we need to worry about is really playing the animation, and we don't necessarily need to worry about the AI knowing that the target got hit. So even easier than creating a task, it's just going to be to play the right animation. So we could say play animation here, and then we're going to get the animation player. So let's see, new BB node. We can assign a saved value to the animation player here. And then the animation we're going to play is attack. That just means now we need to get the target using a sensor. And when we play the animation attack, we want to put a lock so that our regular animation code doesn't run until we release the lock. So let's start with getting the target. So creating a sensor. A sensor is usually going to be area 2D based, in my experience at least. So I'm going to right click on the base node, add a child node, area 2D, add it in. So an area 2D does not affect physics directly. It is only for reading objects that are inside of the area or objects that have just left the area. So knowing if a player entered with the area 2D is really straightforward. So let's say detection zone. And then we will right click, add a child node, and this will be a collision shape 2D. I'll make it like a rectangle shape. Let's put it right over here to the right. So like right in front of where our character is. And I'm going to put this under the facing. So detection zone goes under facing so that when the facing flips, the detection zone flips to the left side of our character as well. Now we need to put a script here to detect the player. So right click, attach script, detection zone.gd. So we'll say class name, let's just say detection zone detects when a player enters and leaves the zone. So I have a var target, which is going to be node 2D of some kind. Or we could even just say it's like a character. I think that's fine. So character extends character body 2D and the setup. So when you have a area 2D, you have these signals, right? So you can connect to the signals from within its own script. So if I do something like function underscore ready, and we want to do body entered dot connect, and we're going to connect it to on body entered, and then we'll do body exited dot connect underscore on body exited. Okay, so now we need to create those functions. So function on body entered, which is going to take a body of a node 2D. So when any node 2D enters, this event triggers, and then we can just check if it is a character, and if it is, we'll just set that as the target. The would be multiple ways you can keep track of targets. You could have an array of targets and then prioritize them and everything else, but we're just keeping it simple as much as possible. No need to get extra complicated. So if the p body is a character, let's just say, yeah, sure. Then we'll make the target the character. So target equals p body. And then on function on body exited, p body node qd, we'll say if target is equal to the p body, then target equals null. So this removes the target and this sets the target. Now, this is basically allowing any character to be in there, so that would include other enemies at this point. So what you can do, rather than needing to code extra differentiation, I mean, you could just make it like player in the script, but another way you could do it is in the detection zone, you can change the collision map, and you can just make it so that the mask only targets a player layer. So if we say mask on 2, and then we click here, edit layer names, we can just say 1 is world, 2 is player, 3 is enemy. And now if we're masking for layer 2, that means that we're only targeting players. So even if any character is allowed in here, only the ones that have character, only the ones that have player as their collision layer on their character body 2D are going to be picked up. So before we go ahead, we should make sure that the player, if we click over here, is in fact on collision layer 2. And if we want to remove it from the standard world collision, so that like enemies can pass through it, we could also remove the player from layer 1. That would be an option if you want like characters to be able to pass through each other. Just FYI. Don't think we need it for this series. Don't think we need that for this series though. So, okay, back to Krabby. So we're targeting players. If a player enters, we get that. What we want to do now is probably to link this up with the BT player's blackboard so that we can bind the target variable with the variable on the blackboard. So I'll do a export var. Let's just say BT player. So BT player. And then we'll get that blackboard. We'll type blackboard. So on ready, we want to get the blackboard to be equal to btplayer.blackboard. And then we want to bind the variable on the blackboard. So blackboard.bind variable to property. We're going to say, or I guess we need a new one. So bbnames.target var. This doesn't exist, so I'm going to copy this name, right click on bbnames, look up symbol, go in here, static var, target var, string name, and we'll do target. Once again, this list is just shared string name, so we only have to write once and share everywhere. Okay, and we want to bind that to this object, but the target property. Argument 3 should be string name. Oh, okay, yeah, right. So we want, in quotations, target, the name of this property up here. Okay, so now whenever we set the target, it should be updated on the blackboard, which means we come in here, we should be able to pass the if null condition. If the cooldown has occurred, so 1 second has elapsed, and we could say this starts cooled. So like the first time we encounter the player, we don't have to wait a second to be able to do that. Don't think we need anything else there. So the last thing we need to do. So now we need to set up the attack animation for the Krabby. So let's go to animation player. Let's create a new animation. I'll call it attack, just like how we set it up in the AI. So this is playing attack, all lowercase. Actually, it would be quick to duplicate from a different one. So I'm going to go to idle and let's duplicate this. I'll call it attack. Okay, now in attack, we want to click here, change the animation to attack. And I'll hit play. Let's see how much frames we actually need. So the ones that have these empty dots here are frames that don't exist. So it's putting it at a value which is already past where the attack animation would finish. So we can delete all of those, change the duration to 0.4. And there's our attack animation. So I'm going to make this not loop. Now what will happen now, I expect, is that when this attack animation plays, the base script, which controls animations here, if I scroll down to select movement animation, is just going to override it and play a different animation. So we need some kind of lock when we play a special non-movement animation to make it so that our NPC stops playing other base animations until we return control to it. So let's create a function here, lock movement. and then function unlock movement. So lock movement is going to take var, it should be lock animation actually. So var locked animation equals false. So coming down here, when we lock, we set this to true. When we unlock, we set this to false. It needs to be a function so we can call it on the animation timeline down here. And we're going to rename lock movement to lock animation. And then this is also unlock animation. Okay, so to make this actually do something, if locked animation, so up here, then if locked animation, we're just going to return. And now we just need to call these functions lock and unlock at the start and end of our attacks. So let's enable snapping, zoom in, make sure we're at 0, 0. I'm going to add a call method track on the Krabby script. We're going to right click, insert a key. We're calling the lock animation function. And then at the end, we right click, insert key, unlock animation. And that's probably all we need to do for preventing this script from overriding the animation. So if we hit play now, let's see if we can get those attacks in. Okay, so first off, we haven't set the blackboard. So if we click on the detection zone, we need to assign the BT player. Let's hit play again. Okay, let's see if we can get some attacks going. Well, if he's actually going to stay in one place. It might be easier if we set like a few duplicates. That would also help us determine if they're accidentally attacking each other when they shouldn't be. So I'm going to hit play. Do we get any attacks? Okay, so one thing you can do for debugging is actually to click debugger and go to LimboAI and click on one of these trees. And you can see where they're actually at in their sequences. So right now it seems like the target is not really getting set to true. What we could do in the Krabby scene is like when the target gets set, let's do like a set value here, target equals value, and then let's say new target %s on %s, and then we pass a percent and then array here of let's see, the target value, and then get parent, which would be the, no, that would be the facing node, wouldn't it? I guess I'll just say this name. So new target on the detection zone name, I guess for now is fine. So we can see the Captain Clown Nose is getting set to a target. Let's rerun that so that you can see. So it's like trying to figure out why it's not playing the animation. Maybe what we do is let's make this actually both sides, because I saw that the attack animation actually detects both sides. Okay, so another leaf you can add in here is actually a console print. So I could say here attack, so that we know that it was trying to attack after the cooldown happens. Let's also check the debugger. Can't bind a variable that doesn't exist. That's probably what's happening here, honestly. So if we click on the BT player, we have the target here. Maybe we just set create to true. Okay, now let's see, does that change anything? So if we check the debug log here, we can see that attack was triggering, but it wasn't really playing the animation, which makes me think it was like overwriting. So let's actually see if that return, if locked animation actually occurred. So I'll hit play, and I don't see that happening. So yeah, maybe that is what's up here. Okay, well, I guess the cooldown has to have only one child task, so we could make that a sequence. So we play one sequence after the cooldown, then we move these into it. Okay, there, that should solve that. Hit play. Okay, now it is actually hitting locked animation. So if we hit play, is it actually playing the animation? I saw it play there once. Okay, first off, I kind of want to slow down how fast the character's moving, I think. So let's go into its character stats and make the run speed 200 or 150, and then maybe 50 for the max attacking speed. Okay, and although the attack is occurring, it seems like it's still trying to move the character when it's doing an attack. I don't exactly want that. So if you click on play animation, what you can do is you can await completion. So let's say 1 second, await completion. This will make it wait for this before it continues on to the other ones. So if we hit play and then we have it do an attack, then it's actually going to stop, right? It looked like it, but let me hit play again. Okay, so that's a little bit closer to what we want. Maybe it would make sense if we just make it able to detect the player on both sides. I don't know, that's kind of debatable because it is looking one direction, but it can attack both ways. So let's see, how does that work? Oh, it seems a little unfair. So maybe we would also want to like put on like a delay. So like we delay sometime before we go into this attack. So let's just say 0.3 second delay. But we do still want it to use gravity during that time, right? So let me see, is it still applying gravity during physics process? Yeah, it should be. So yeah, that's probably good for like a basic setup. Obviously, there are some tweaks to be made here and there, but I think this is like a decent working prototype. And at least it kind of demonstrates how you can like set up your behavior tree hierarchies to control like what happens. So like if you have target equals null, then it's going to skip all of this and just go straight to moving around. You can also use that kind of check for things like, oh, is the character on the ground? Then if it is, then you could allow it to do jumps, and that could be part of your AI. In this case, I just kind of combined that sort of movement all into the navigation to point task. Just because I think if you have too many separate tasks, it can get a little bit cluttered up here. But I think that'll do for right now. So possibly in the last video, we're going to work on getting the enemies' hit colliders and the players' hit colliders to work, just so that they can damage each other. So hopefully I'll see you guys in the last video. Okay, so we have like a basic AI working for our character. It can detect when the player is within range and do an attack motion. Our character can attack, has air attacks, and so on, controlled by a state machine. The enemies are a behavior tree, obviously along with a navigation agent, and they move along the navigation map. But they can't actually damage each other yet. So we're going to add that in as kind of a wrap up to the course. So in order for a character to damage another character, you're going to have first off some kind of health component. And then you'll pick that up from the character trying to hit the other character and deal damage to it by subtracting an attack value. So I will try to keep this straightforward. We would want maybe in character stats we'll have like a damage. So let's say stats, character stats, and let's just add in at export var damage, which can be a float, and I'll default it to 10. Okay, so now we'll be able to read from that when we are dealing damage to an enemy. So for our attack, we need it to have kind of a attack collision or attack collider. And that's going to be attached to an area 2D. So I will right click on facing. Let's say add child node, area 2D. And we'll just call this attack area 2D. I'll right click on it, attach a script. And this will go under characters because the player is going to use the same script. So create the script. We'll just call this class name attack area 2D. Used for hitting health components. Sure, let's go with that. Okay, so a lot of this is going to look kind of like the detection zone where we're going to connect to its own signals. So inside of here, function ready, we're going to have body entered dot connect on body entered. I think we only need the body entered though, because we don't really care about when it leaves the zone. We're only dealing damage when it enters. So function on body entered, which is going to be a body as the parameter, of course, node 2D. So if the P body is a character, let's just say. So if we're hitting a character with the attack, then we can kind of access these stats on the character. It could be a separate health component, but you know, I think basically any character in these kind of platforming games that have attacks are just gonna have like a health stat too. So in character stats, I'll just even put in the at export var health into here. And let's just make it 20. So a character can take 2 hits before dying. We could also make these integers. Most games, they don't really deal floating decimal point damage, so that would make it kind of unnecessarily hard to read. It's easier if you just see like 10 rather than 10.0 or 10.5. So if the object that entered was a character, then we'll say p body dot we'll create a hit function, and we'll pass in the amount of damage that we're going to deal. So we need a reference to the character stats. So let's say at export var character. So this is the character doing the hitting. And you might like have multiple attack damages. Like you might attach the damage value to the attack area rather than the base script. You know, that actually makes sense. Let's just put the damage in here. At export var damage equals, it's an integer, and I'll set it to 10. And then we'll remove damage from the character script. The reason for doing that would be that you might have different types of attack areas for, let's say, different attacks. So being able to set a custom damage value for each one is pretty handy. To go beyond that even further, you might have like resource files which contain attack values like, oh, the name of the attack, the damage of the attack, so on and so forth, kind of like an ability system. But once again, keeping it simple here. So we're going to hit the other character with the damage from this attack. And that is pretty much it. What we can do is say var damage dealt, and then we can print, let's just say dealt %s damage to %s. We pass in an array, so percent and then array. And we're going to do damage dealt and then keybody.name. Okay, that way we can just see that this is actually working while we're kind of testing and debugging the game. So our attack area here is going to collide with, of course, players. So set that up, and we want it to be essentially not triggering by default. So the way we can do that is by adding a collision shape. And this will be, let's say, a rectangle again. And I'll just kind of make it the shape of the attack, which we can see there. I might pull it in a little bit, make it a little more fair. And then this is going to be disabled by default, of course. So we can do that by going to the animation player, going to reset, add track. So the collision shape here, we want to set it to disabled. Insert key, snapping to 0.1, and then make the snap to 0.0, disable it. Okay, so that means after an animation finishes and it resets back to another animation, it's going to disable the collision shape. So hopefully we won't have to worry about it triggering like that on other animations that aren't this one. So here, yeah, we can see that we need to add in the, first off, we need to enable the shape. So disabled should be off here. And then we need to stretch the shape depending on which frame it's at. So I'll click on the collision shape. Let's go to transform, keyframe the scale, might as well keyframe the position as well. Go to frame 1, increase the scale X to fit our frame 2, and then keyframe it. That adds a keyframe point down here. Next frame, we can go a little bit further like that, keyframe it. And then by here, I think it already should be disabled. So I'm going to insert a key actually, and we're going to disable it there. Okay, and we might want to play that animation. Oh, okay, so we can see it's kind of like automatically growing with time, but because it's pixel art, we want to change this continuous scaling to discrete, so it only changes when the keyframe changes. So now it's going to look like this, right? Much more appropriate for this style of game. Okay, so that's going to enable the attack area, which already calls hit on the character. So let's jump into the character script. We go to character, we'll create this hit function. So p damage, right? That's how much damage it's going to take. And we're going to say stats.health minus equals p damage. And we can go into character stats. You might have like a max health here. In the actual game, you might have like a max health here, and then whenever the character gets created, you set that starting health to the max health, but I'm just going to skip that. But when the health gets set below 0, so I'm going to do a setter on the property here. So set value, health equals value. If health is less than 0, then I'm going to emit a signal. So our stats resource can have its own signals. So signal, I don't know, health depleted. So if the health is less than 0, then we'll say health depleted dot emit. And now we can react to that signal. Okay, so on the Captain Clown nose, let's add in another state on the Captain Clown nose. So this will be a character state. I'm going to rename it to be dead state. Okay, so for our dead state, we want to be able to transition into this when the character's health drops below 0. So one way of doing it would be to go onto the HSM. And let's add an event handler. And then let's bind a signal to the character stats. So I'm going to say character.stats. Oh, I see this is still a character body 2D. Then let's make that a character. Okay, and that doesn't unset the reference here. So character.stats dot health depleted, and we'll say connect to on health depleted here. Come down here to the bottom. On health depleted, we want to just change the active state to be, let's say, states dead. Okay, so then we just need to make sure that dead is added in here. So assign the dead state, add key value pair. And that's how we're going to get to that. So when the health is depleted. Now let's see, in character stats, when we do this, I also want to make sure that the old value was actually above 0, so that if the health keeps dropping below 0, like 0 to -5 and then to -10, that we don't keep emitting this. So we'll get the old value. Old value equals health. So and old value is greater than 0. So only when it drops to 0 or below 0 for the first time are we actually going to emit that signal. Okay, and then on dead state, well, we have the animation name here, so we just need to play the animation, which we haven't created yet. So let's go to idle. I'll duplicate that. Let's call this the data animation. Put data over here on character state. Change the animation here to dead ground. Sure. Hit play to test. Okay, looks like this is a 4-frame animation. It should not loop. So unloop it and then change it to 0.4. Can hit play there. And what we can do is at the end of this animation, we'll just do a call method track on the character clown nose, insert, and then cue free. So that'll just remove the character from the game when the character dies. Let's hit play and see if the character can actually take damage. Oh, there we go. And yeah, it looks like it takes 2 hits to actually defeat the player. So that was pretty much exactly what we were looking for. We want to kind of do the same thing with the crab now, right? So for the behavior tree, let's see. I would say we want to bind the health in the behavior tree so that we can actually keep track of that. And then if the health drops below 0 here, then in the tree we'll have a prioritized sequence here where it'll just destroy the crab. So let's click on BT player, edit. We'll add in a health variable. Actually, we don't need it because it's actually already on character.stats. Okay, so let's click on BT player and we're gonna add in a health variable, which is an integer, health of the character. And then we're gonna go to Krabby. So this is the NPC. So the NPCs are all basically behavior tree based. So we should just bind the stats to the behavior tree. So I'll say function ready, and we'll say stats.health. We'll say bind. I guess we need to reference the behavior tree for that to actually work, huh? Okay, so at export var behavior tree dot player underscore player bt player. When we load that, then we'll get the blackboard. Okay, so blackboard equals the bt player dot blackboard, just like before. And now we bind on the blackboard, blackboard dot bind variable to property. We're gonna do bb names dot health var. That's going to be equal to, I guess the stats is the object and the property name is health. So assign the BT player there. Health var doesn't exist, so jump into BB names. Put in static var, health var, string name is equal to health. Okay, back on that script, we just save it. Make sure everything's still assigned here. I'll reset these animation names. Make sure they match up with these down here. Okay, and then we can go to LimboAI, create another sequence here. We'll call this defeated sequence. So first thing we're going to check is if the health var is equal to 0. So the type is integer, the value is 0. If health is 0, or actually less than 0, less than or equal to 0, then we're just going to play the death animation on the character. So this would be animation. Let's get the animation player here. And then we're going to play dead animation. And then we need to create the death animation on the animation player. So yeah, let's duplicate the attack. I'll call this dead animation. We delete the collision shape stuff. We're going to leave the lock animation, unlock animation, because we still need that. And we're going to change the animation here to dead. Okay, so let's go up here. Let's hit play. And I don't know how many frames that is, so let's check dead ground. Oh, okay, it was actually 4, huh? So this is already almost what we need. We could add like a couple extra frames here for the duration, and then move this over here if we want the character to stay dead on the ground for a second. And then let's do a call method on Krabby. We're going to free here. So Q free, hit play, and that should mostly be working. We just need to have the attack. So we have the sword collider here. Let's add in the attack script. So attack area 2D, drag and drop that to here. We have the damage. Okay, first off, let's reload the current project because it seemed like there was some animation path issues. So that usually fixes things. We hit play, we go over here. Okay, our character died. Let's change the player's stats to be higher. We already know it can die, so let's just make it 200 so that we definitely don't die. And then let's try to go and swing at these enemies. So that guy died. Oh, I see that they're all of their health is actually linked up. So what we want to do, if we go into the NPC script here. So let's see, character stats. I think we'll just want to like duplicate this immediately. So we're going to say stats is equal to a duplicate of the value, or value.duplicate. Okay, this means that for each active character, it's going to have its own stats. They're not going to share the resource directly. Otherwise, they would all die at the same time because their health values are all shared together. So now if we hit play and we try to damage these characters, you can see that they don't die at the same time. So that's more like what we're looking for. And all the death animations are able to play. So if you're interested in like hit knockback and that kind of thing, I have other videos on the subject, but I think I'm going to actually wrap this series up there. The main things we covered is how to set up some examples of a branching behavior tree. So here we have death if the health changes to below 0, which is our first priority. We can attack if we have a target, which is picked up by the sensor. And then if we have a fallback, then it's just going to navigate around the map until we find a target to fight or until the player hits and kills our character. Then on the clown nose, since a player character doesn't really need its own AI logic, we just set that up with a Limbo hierarchical state machine, and that just allows us to transition between the different states that have different properties about how the character can move or not move, and creating all of the transitions from within the state machine's base script. So there is a lot more to cover on the subject, but I hope that this video has given you a good introduction, that you'll understand roughly how to use state machines and behavior trees as well within a Godot game using LimboAI. Although I used LimboAI for the video, if you want to check another example of a behavior tree system, Behave, spelled B-E-E, like a bee, and then have, is another good option for within Godot. So you can definitely kind of compare those two and see which system works for you. But that's going to be it for this series on LimboAI. If there's enough support for it, then I might make a full course at some point. Let me know what you think, what you thought. Did this help you out, etc.? And until my next video, I've been Chris. Thank you guys for watching to the end, and I will see you in my future content.